Hi everyone, good morning, good afternoon, and good evening. Welcome to yet another second edition of the Localhost Conference. Can we all confirm that we can hear me on YouTube by dropping your comments? Let's know that we are live because I cannot hear you, only you can hear me. Oh yeah, you guys can hear me. My name is Victor Ichofu, and I have been with Localhost for I think 4 or 5 years, and this is the third or fourth year I'm handling the sessions in a row. Last year I was not available, as some of us know, because I was out of town, but I'm glad, we are doing it remotely, so we can all join from wherever we are. So before we start, I want us to say where we are listening from. Write your name. I can see your name on YouTube, so you can write the country you are currently listening from, and maybe drop a flag. Let's see how far we are connecting. Me, I'm currently in Canada, and it's 5 a.m. here. I'm sure in Nigeria it's 10:03, 10:04 now. So let's see, where are you listening from? Victor hosting from Canada. Yeah, I can see listening from Germany, Promise, Lagos, Ifeanyi, Asonye, Lagos. Lots of 2, 3, 4 flags up there. Thanks for joining, guys. Thank you for joining. I can see Emmanuel, I can see Michael, I can see Fasted Gist. Sorry if I didn't get that name correctly. Okay. Thank you very much, guys. I'm glad to see that we are all, well, most of us are from Nigeria anyways, which is also good. And I'll assume some other guys have not woken up yet. Oh, we have Tolu Fakiyesi from Hong Kong. I know that Tolu. Tolu, I greet you. So yeah, now we are going to just kick off with an introduction from, hold on a sec. We are going to kick up the conference with an opening remark from Idowu. I don't know how I want us to clap, but if we can drop the clapping emojis on the YouTube comment section, it would help know that Idowu is appreciated as he comes to the podium to give us an introduction about the Localhost Conference 2024.
Hello, Victor, please confirm you can hear me.
Loud and clear.
Okay, awesome. I'm really excited to see everyone joining. I've been looking at the comment on YouTube. I'm actually very happy that a lot of people can still join, even if the program is, the conference is virtual this time around. Welcome everyone once again. The Localhost community has been around for almost 6 years, and this community began with just a small group of people coming together to want to preach the gospel of DevOps beyond the corner of their organization at the time, sometime in 2018, and the mission had been to always improve the technical knowledge in Nigeria. We started from Nigeria, the technical knowledge of everyone in relation to DevOps, in relation to DevOps tools, DevOps culture, DevOps processes, SRE, system engineering, and everything revolving around that. Beyond that, we've been able to also elevate this to the countries like England, where we have some people there having communities stemming off the current Localhost community. We have myself in Germany also doing the same thing. We have Vichofu, we have Victor in Canada, also doing something like that. Basically, the whole idea is to make sure that DevOps and everything revolving around DevOps is communicated properly, is taught properly. People get answers to their questions and everything around that. Between the year we started and now, we've done a lot of conferences, we've done a lot of meetups, we've held a lot of Twitter spaces, we've had programs or boot camps that has helped people called the DevOps Accelerate, that has helped people to kickstart their DevOps journey and even be qualified to be hired remotely or relocated to other countries outside Nigeria. I also want to use this opportunity to thank our sponsors. They've helped us throughout these 6 years of the community. They've been with us throughout. They've sponsored our events. They've been available to help us financially and otherwise, and we are really, really grateful for their support. We also want to really thank our speakers. Over the years, we've had several speakers come on to share from their wealth of knowledge, communicate with people. We've had mentors for our DevOps Accelerator programs that have also helped improve people's technical knowledge. We say a very big thank you to how you have made yourself available, and we hope that we can see you in the future. Most especially for this conference, we want to say a big thank you to DevOps Dojo for their support, and also say a very big thank you for the speakers that will be coming up today to share from their wealth of knowledge. And we hope that they will be able to communicate effectively to everyone, and everyone will be able to learn one or two things before the program runs out. Thank you very much for having me. My name is Idowu, and I really hope everyone enjoys the rest of the conference. Bye.
Thank you very much, Idowu, for that warm introduction. It's good to always know that you are always there when we need you to be available for the Localhost community. Thank you once again. Before we continue, I mean, for those that, some of us know me, for those that don't know, I like to do giveaways in these conferences. And I mean, the fact that it's virtual does not mean you will not still get something. So we have about 100K that will be going out to various people at the end, on or before the end of the conference. And there are various parameters that we are using to check. Someone is going to win 50K. Then the other 50K, we can determine, do we want to give it to one person or do we want to spread it? For the first 50K, the plan is for us to go through social media, tweet about the event using the hashtag. Favor would share the hashtag on the screen and use the hashtag to drop tweets, drop pictures on Twitter, on LinkedIn, anywhere. And we're going to go to Twitter, check the hashtag. Whoever drops the highest tweets for today is going home with 50,000 naira transferred during the show. It is not, we'll give you after the close of service, or we'll give you after the event. You are receiving the 50K before we share, no, let me not say before we share the grace, before the show comes, before the conference comes to a conclusion, you are most likely going to get the 50K. So get your phones out, tweet about the event, invite your friends that are not here yet. Yeah, that's just it. That's for the first 50. The second 50K would be tied to people that are engaging. You are dropping comments on YouTube. You are asking questions. Just be creative and do whatever you think you can do. We will be seeing this engagement. We will be seeing these activities, and that's what will be used as a criteria to give out this remaining 50K. But the first 50K, we are certain whoever drops the highest amount of tweets on Twitter is getting that 50K. So get your phones out, keep tweeting. Don't I like that you guys are talking on the YouTube page, but also go to Twitter, go to LinkedIn, and drop your tweets using the hashtag favor. Yeah, that's the hashtag on the screen there. Localhost Conf 2024. Right about now, we'll be getting our keynote speaker, an AWS community hero, Ewere Diagboya, to come up to the platform, the podium, and give us his keynote speech for the conference today. Thank you. Ewere, are you there? Okay, Ewere is trying to join. Let's give him a minute. While Ewere is trying to join, I'm going to Twitter as we speak, and I would be keeping track of the tweets. And we will all see who is currently on track for the 50K, and we'll take it up from there. So yeah, I think Ewere is here. Ewere, thank you for always being there for us, and podium is yours.
Thank you very much, Victor, for the introduction. Hello, everyone. Thank you very much. It's been a pleasure. And it's a pleasure also joining our Localhost Conference. So without further ado, I'll go straight to my keynote conversation. So my topic is AI and infrastructure engineering. I know that AI has been the wave of the moment, but we are not going to leave the infrastructure guys out of it. We have seen that AI is disrupting a lot of spaces. So let's discuss how AI is also going to affect. Let's see how AI is also going to affect other aspects like our own focus, which is on infrastructure engineering. Please, I need a confirmation that you can hear me. Can you hear me? Can you hear me? Can you just comment that you can hear me very well? Okay, thank you very much for that confirmation. I needed to be sure that I'm heard. Okay, great. All right, great. Okay, so let's get into it immediately. So first of all, I'm going to talk about myself. I have 20 years experience in the DevOps space. In the technology space. I started writing code as far back as 2003. And I have 9 years experience in infrastructure engineering, including DevOps, including data ops, including generally infrastructure, cloud infrastructure. I'm also the first AWS community hero out of Africa, and also the only one in Nigeria. We're hoping to get more heroes right here in Nigeria. And I'm also the author of Infrastructure Monitoring and Dictionary, which are my 2 books that are shown there in photos. And I'm also a 2-time judge for Cyber Girls Fellowship. It's a fellowship where females are trained in cybersecurity, and I've been a judge last year and this year to help to evaluate the work they've done in terms of infrastructure security and generally cybersecurity. I'm also a speaker. That's what I'm here doing. I also blog on Medium, medium.com/mycloud series, where I share my thoughts, my ideas, my learnings, and everything around that. Okay, without further ado, let's go forward. I'm not trying to steal someone's line. Okay. So what is artificial intelligence? It's been a trending word. It's been something that everyone is talking about, AI. But what exactly is it? Let's break it down into the most basic terms. AI is teaching a machine to learn using data and mathematical algorithms. So basically, what AI means, or what the concept behind AI is, being able to teach a computer what to do. Computing before now, in the past, say 60 years or 70 years, it has been about garbage in and garbage out. You hear people tell you that, oh, a computer does not have a brain. Whatever you give it, it will give out. Very true. But if you think about it critically, humans are also like that. So computers are not as dumb as we think. Most of the time, it is what you teach a child, that's what the child knows. Okay, whether it is verbally taught or inferentially taught. What I mean by that is whether you tell a child don't to do this, or the child sees you learn it, the child learns from you. That's exactly the level computing is getting into, where the computer does not just do garbage in, garbage out. Instead, the computer takes in your questions, re-understands your question, and gives you a response. Now, what makes AI unique in terms of the way it behaves is that when you give an AI a question, it doesn't respond the same way every time. I'm sure a lot of us here have used ChatGPT a lot, so I'm sure you guys are superstars when it comes to the use of ChatGPT. If you check ChatGPT very well, when you ask a question and it gives you a response, if you ask that question again, the response is different. That is where the intelligence comes in. And it's able to do that using mathematical algorithms. So the difference also between this and your normal database engine, where you write a query and you get a response. If you write a query in your database, you're going to get the same response every time. If I say select star from where name is equal to John, if I run that query 50 times, the response will be John. But for an AI model, when I say who is John, even if it tells me John is a student of Unilag and John did his master's in Cambridge University the first time, if I ask him again who is John, it's not going to give me that response the same way. It's going to say, as a graduate of Cambridge University, John also studied a first degree in Unilag. You see, the way it behaves in terms of responses are different because of the mathematical algorithms and patterns that are inbuilt into that model, gives it the ability to give you intelligent responses for every prompt that comes in. That's where the whole concept of prompt engineering comes in. And also, just the way your Google search works, the better the kind of questions you ask, the better the kind of responses you are going to get from the model. Now that we understand the basic concept of what artificial intelligence is, let's go a bit deeper and understand it from also the technical perspective. So while software engineering gives direct instructions for a computer to respond bidirectionally, what that means is garbage in, garbage out. I ask you a question, you give me that answer. If you type a Word document, you save it in your computer. When you open that Word document, you see exactly the same thing. Okay. AI involves giving it a lot of data to respond based on what it knows. Okay. So the difference between AI again and what computing used to be is whatever you put in, you get exactly the same thing. That's software engineering for you. If you build an internet banking application or you build a shopping website, you add some things to the cart. You expect that phone you added to the cart, when you click add to cart to check out, like the process is sequential. The process is clear. You understand each step of the way, but AI does not work that way. AI kind of checks for other possibilities using mathematical algorithms and gives you responses based on those things that it knows. So the more you promise, the more you ask questions, the more it gives you better answers. And funny enough, it can even take your previous questions and use it to understand you better and give you better responses. So that's where it's called intelligence. Okay, that's the meaning of intelligence. Okay, now let's talk about infrastructure scope. I mentioned that this is AI in infrastructure engineering, the role it plays. Now, infrastructure covers a whole lot of things. Okay, you're talking about data ops, you're talking about DevOps, you're talking about cloud computing, AI ops, which is becoming something trending, SecOps, and site reliability engineering. All these fields have one thing in common. And if you notice, they all have ops in front of them, which means operations. They all have to do with, number one, setup of the systems. Number two, running of the systems. Number three, management. And in some cases, security. That's why I add SecOps there. So basically, infrastructure engineering is building the platform where things run on top of. So the word is similar to when you say a country has no infrastructure. Because for a company to thrive, you need basic infrastructure for that country to work very well. Basic infrastructure like power, basic infrastructure like roads. So the concept of infrastructure is actually transient. It covers almost anything. And it's the same concept we are talking about here. So these are the core concepts that are around infrastructure with certain specializations. So people that are involved in DevOps mostly work with applications, okay? Mostly work applications, they deploy applications, they scale applications, secure applications. And then cloud computing, we talk about the AWS cloud computing, the Azure cloud computing, and all that. And then AI ops too, same thing. Okay, just that what makes each of these fields different are the kind of things that they manage, the kind of things that they are working with. That's basically what makes each infrastructure specification slightly different. I didn't add blockchain ops here, but it's a thing, but you barely hear anything about it. But yeah, it also has to do with how you manage, scale, secure, and work with blockchain-based infrastructure. Lastly, the reason each of these sectors seem different is because of the knowledge that is involved in them. The knowledge you need to be able to manage and work with a DevOps infrastructure is very different from what you need for a data ops infrastructure, because of the data that is involved, you need to understand data as a separate field. So you need to have some knowledge about data engineering, you need to have some knowledge about data analytics in some cases, so that when you are delivering value in that aspect, you're able to deliver it efficiently. Now, where is AI disrupting? Now, we all know AI is disrupting a lot of fields, in the creative world. I mean, there are so many websites nowadays, there are so many bots nowadays, there are so many models nowadays that you can practically prompt that model to create an image for you, and it creates a unique image for you. I don't know what's going to happen to the job of graphic designers in the near future, because a lot of times, if you want to write a creative for some of my articles, when I need to write an article and I need a graphic for that article, I used to have to open my drawing tool, get images from the internet, put them together. It might take a day, it might take 2 days thinking about the concept. But now, exactly the way it is in my head, I prompt the website and it generates that image for me. Saves me a lot of time. There's an article I wrote recently about monocharts for him, and the image there is a man standing where containers are. That was practically generated by AI. Okay, I didn't have to do anything. Just prompt it and it gives me that particular image. So I guess most of the things that we're going to be doing will be based on how creative you are in writing appropriate prompts to get appropriate responses. Software engineering, we know about GitHub Copilot, we know about Amazon Q for development, that practically looks through your code and tells you where you can make improvements and changes, and also optimizations to help your code work better. Medicine, I mean, this has been a field where AI has really disrupted a lot, because in medicine, what happens in medicine a lot is you want to study a cell behavior, a cell structure, and predict if this cell is cancerous or not. And that also has to do with feeding that AI model with a lot of information, where it can actually understand and tell you, oh, there is a high chance that in 30 years' time, this cell will be cancerous. And there are so many other applications in medicine. Also in law, that's another field that AI will also disrupt massively. And then in social life generally. Meta's popular Llama model has been tightly integrated with Facebook, with WhatsApp, and I also think it's coming to Instagram very soon. So basically, how we interact, how we live, how we learn, how we love, AI is practically going to disrupt every single ecosystem, but in phases and in time. Now, we have talked about other phases, other parts of human endeavor that AI has disrupted. What about infrastructure engineering? How does AI disrupt, or how does AI affect infrastructure engineering? It does also, just the way it affects other fields. And let's look at each of the ways you can actually apply AI into your work as a DevOps, as a cloud engineer, as a cloud DevOps, as a platform engineer, whatever name you want to label it. Okay. Now, the first is predicting downtime. When the model is trained with the right data, it can predict the system downtime. So in the space of observability, if you understand observability very well, you notice that observability collects a lot of data, from your logs to your traces to your metrics to profiling, and that's a huge lot of data. Now, if you are able to feed this data into a model that practically collects this data and understands this data, it means that it can actually prompt you and say, based on this data I collected for 1 year about your infrastructure, by 8 p.m. on Saturday, on the 11th of October, you're going to have a downtime for 15 minutes. Okay? You're going to have a downtime for 15 minutes. Now, that is one of the things that AI can actually do for you. And it's actually very possible and very doable. Okay. Another thing AI can also help you with is enhanced security. Don't forget the concept behind AI is teaching the computer. You are teaching the model. You are teaching it that um, um, know my name, know my name, know my name, know my name. My name is John. My name is John. My name is John. I'm 15. I'm 15. I'm 15. When you continue to tell it that in different ways, I'm 15. I am FIFTEN. I am 15. I am. That's exactly what you are doing. You are training it. So it means that the possibilities are endless. So, like I said, borrow the same idea about a child and a machine. It's the same concept. When you give birth to a child, you teach the child how to eat, you teach the child how to beat, you teach the child how to do a lot of the basic things that the child needs for life. And it follows that child to adulthood, to the rest of their life. That's exactly how a machine works, or machine learning and AI works. So it is the information you feed it with. That's exactly, and even behave better than you have given it, because it also tries to optimize the data it has to produce better performance and gives you better results. So sense potential threats in real time and enable better security controls. What we have at the moment in terms of security are usually mostly reactive. Okay, there's, in my book I talked about reactive monitoring, where it's when something happens that you act. But in AI, your monitoring and your security is going to be more proactive, because you have been able to tell this machine a lot of things about your system. A lot of understanding has gone into it. So when it's trying to give you information or tell you something, it's telling you based on knowledge. And the human brain cannot really keep all this knowledge, cannot keep all the information that it needs to know. So what it does is that it picks this information, understands this information, compresses it, and gives you the output in a method that answers some of the questions that we ask in infrastructure a lot of time. Because one of the questions we are asking is, how secure is my system? How scalable is my system? Do I have enough capacity? These are the questions that goes on in the mind of every infrastructure engineer. When you are sleeping at night as a DevOps engineer, you are thinking, please, I don't want to have a downtime by 3 a.m. I don't want to wake up. These are the questions AI will solve for you even before you have to think about solving these problems. Another main point is optimization of delivery pipelines. This for me is one of my favorites. Pipelines are the core of DevOps and delivery of software. And a lot of times, people build pipelines based on emotions, not based on reality. With the information you feed your AI with and other information, because the way you feed your model with information matters a lot, because it also has its biases. If you feed it with bad information, you will get bad output. If you feed it with good information, you get good output. That's exactly how it works. Nothing more, nothing less. So it means that you need to look for the best type of information. You need to look for industry standards to feed your models with so that you can get the best results. Now, for improving deployment time and CI coverage, first of all, deployment time. How optimized is your CI/CD pipeline? Do you think your CI/CD pipeline is working the way it's supposed to work? I don't know. Question to ask. Do you think that you can improve your deployment strategy? Oh, yes, there's always room for improvement. But sometimes you might be limited by not knowing or Googling and feeling like, no, I can't do exactly what they are doing. This is where AI comes in to help you look at what you have in your system, look at your script, your GitHub Action script, your GitLab CI script, your Jenkins script, I don't care what it is, and tell you know what, the part of you are building your Docker image is taking you 8 minutes to build it. Why don't you add caching layer to this? Maybe it will improve your build time by 3 minutes. That automatically improves your delivery time. And then for CI coverage, maybe your model will look at your CI script and say, there's no test. You might need to add unit tests to your system so that you can improve your delivery and deliver more efficient software to your users and to your customers. And then lastly, assist with capacity management. This is also one of my favorites. Planning, forecasting, scaling decisions, hardware procurement, and resource allocation. Like I said, most of the things we do in the infrastructure space are very reactive, mostly reactive and based on assumptions. Most times not based on data. Even if we have a lot of data, most times there's still that emotional side that comes in. So for example, you work in a data center and you're asked about capacity. And when you are asked, okay, how many servers do you think we need? Most of the time you guess. That's the truth. You say, okay, last year we needed 2 more. This year, maybe. You have no idea. That's the truth. But when you have AI, okay, when you have AI models that can help you with this thing, with other kind of information that he understands that, oh, this Ukraine war will continue in the next 1 year. Based on all the information I know there will be, this war will continue. Your business is actually an e-commerce business that deals on wheat. It means that more people will buy wheat next year because Russia has purchased more weapons. So there's a high chance that there will be more bombings in Ukraine. Ukraine will not produce more, which means you need more infrastructure. That is data and AI giving you insights to perform better and produce better results. So your decisions, your choices, the way you design your architecture, the way you orchestrate your systems will always be based on inferential data, unbiased and unemotional, so that your systems can get the best performance and get the best delivery. Okay, as I conclude, by reducing manual intervention and increasing operational efficiency, AI can reshape software infrastructure engineering, making it more agile, resilient, and aligned with evolving business models. That's my conclusion. And a footnote here is that AI is not going to take your jobs. Thank you very much, and have a wonderful rest of the session.
Thank you very much, Ebere, for that wonderful session. We would also like to take questions. If you have questions, feel free to drop them on the YouTube comment section, and Favor would take them up now, and Ebere would answer your question. So if you have any questions, feel free to drop them now before Ebere leaves the stage. Yeah, while we wait for the questions, I can see a few handles on Twitter that are trying to win my 50K, and to cast the person leading that dashboard now, I just refreshed my screen now, and I am seeing Tife Mike, that's Wale Buluwa Tife, is in the running for my 50K. If I were you, I will pursue him or her. Yeah, I think there's I think there's a question. Is there a question here?
Yeah, I think there was a question before. I just wanted to quickly answer it. When I was talking, someone asked a question.
Okay, please go ahead.
The person said that I did not mention DevSecOps. Why? So if you check my slides, I wrote SecOps, okay? Because SecOps is a separate entity. DevSecOps sounds a bit complicated, okay? So that's why I didn't mention it, but no offense to DevSecOps. DevSecOps is, you are combining 3 people at the same time, and most times it's almost impossible to integrate. So if you say SecOps, it makes a lot of sense, because some people actually do SecOps, that they're security professionals that automate stuff and manage security systems. That's SecOps. DevOps are people that automate deployments and management of systems. But if you say DevSecOps, it means one person is handling development and deployment and security, and which most times is not very possible. Okay, either the person will be very good in security and not very good with DevOps, or the person. So most of the time, I try to avoid DevSecOps, but I know about the buzzword about DevSecOps and what it looks like. But I would prefer to stick safely to SecOps. Imagine someone is saying, I'm a DevSec AI data ops engineer. Doesn't make any sense. So some of these are just names, but the most important thing is, delivering value to the business. I hope I answered that question.
Thank you very much, Ebere. I think there's another question on the screen by Fast Gist. What is downline?
Downline? Okay. I get it. The question doesn't look complete. I think I talked about downtime.
Downtime, that's what I would assume too.
Yeah, sounds more like question asking.
Yeah, I think I can see it.
Downtime is when people can.
Go on, sorry.
Okay.
Go on.
No. I'm just trying to say that since we assume it's downtime, I just wanted to say that downtime means that when you can't access someone's system, the website is no longer available, and something like that. That's exactly what
Okay, that's
time means.
thank you very much, Aurelio. I think I can see a question here from Samuel Ekele. Don't you think AI will disrupt DevOps? We may soon be seen as AI DevOps agents or something like that. What do you think?
Yes, like I said, AI is going to disrupt every ecosystem. And the narrative now is core backgrounds are what will guide every single sector. Okay? Just the way DevOps would disrupt, just the way AI, would disrupt DevOps and SRE, AI will also disrupt software engineering. There are some AI tools now that you just type, build an e-commerce website and mobile app for me, and it generates both of them for you and gives it to you. They exist right now. So just the way you can tell an AI model, build a CI/CD pipeline for me for Node.js that will deploy to Kubernetes, it's going to work. But the question is, the biases that are in AI are where the loopholes exist in AI. So for example, you can write that and it will pick from the best practices and give you a pipeline. And that pipeline might not be optimized. Let me give a very basic example with myself. Recently, I talked about it during my talk. Recently, I wrote an article about a mono chat, and nobody has talked about mono chat in this world before. We have been using Helm chats for many years, and all of a sudden it came to me that why do we have to have a single Helm chat? Why do we have to have Helm chats on every single repository? You have 30 repositories in a company, 100 repositories. Each repository has a Helm chart, and Helm is a templating engine. Why don't I just have a single Helm chart that works across all my repositories? And I wrote an article on it, and that article has gotten over 2,000 views and over 1,000 views on Medium. It's one of my best articles this year. That tells you that there is still a human touch to the nuances of what AI will give. There are still some things AI will not know. Don't forget, it is what you teach AI that it knows. So the more information it gets, the better it will become. But there's still the human factor of being the innovator in it that I don't think AI is ready to take away at the moment. So yes, AI will disrupt DevOps and SRE, but it is still the core professionalism and the core underground background knowledge you have that will still stand you out, even in the whole AI disruption. Yeah. Any other question?
Thank you very much, Eri. I think I saw a question earlier, but I can't see it again. The person was asking about AI tools in DevOps in engineering, I think. Can you mention some AI tools presently used in DevOps?
At the moment, they are not really core AI tools, because the truth is that AI will not be tools anymore. AI is going to attach itself to things. For example, there have always been chatbots before AI. Now, when you combine an LLM model to a chatbot, it becomes a GPT model. That's exactly what's going on. So the ChatGPTs, the cloud, they are still riding on top of the waves of the existing systems. So you might not have AI tools. What will happen is AI will partner with the tools to do them better. For example, I'm hoping GitHub will launch something like that very soon, maybe in GitHub Actions, and say, okay, analyze your GitHub Actions to improve it, something like that. Because what they have now is Copilot, and it's mostly for programming, okay? But you should be able to also highlight your GitHub Actions, and the Copilot will tell you, oh, your GitHub action needs to be better, or your Terraform code, you did not add policy enforcement in your Terraform code, make it better. That's exactly how AI is going to integrate into DevOps. But there won't be like, oh, this tool is for DevOps engineers and AI to know. If you check the way AI is being implemented, that's not how it's working. It's improving existing systems. That's why I mentioned before that your core, based on the understanding of systems and things, will what should stand you out, even in the whole DevOps, in the whole AI noise.
Thank you very much, Eri, for that answer. I have another question from Okunade Orel Olua. He or she has asked the question at least 100,000 times. We've seen the question and we would.
Oh my God.
We'll respond to
Please
it.
answer the person before they come after us.
So the question is, in your experience, what skills are most important to develop? What skills are most important to develop for working with AI in infrastructure engineering?
Okay, I mean, it's very new, even to me, I won't lie, because everybody's talking about AI in programming. Everybody's talking about AI in getting results to your answer. I mean, I saw an article today that was saying that is Google now becoming obsolete because it's quicker to get responses from ChatGPT than Googling them. I mean,
I agree.
almost instant. What am I using Google to do, for God's sake? Scrolling through pages and Stack Overflow. You get. So the answer to your question is, it's still evolving, okay? But that doesn't mean you should sit on the side and wait, because by the time it's done evolving, it will be too late for you. Same thing happened to the software industry. When in 20 years ago, 30 years ago, when the Pythons were being developed, Java were being developed, people said, we are using COBOL and Pascal. That's real programming. Hello, 20 years later, what's going on? Everybody's writing JavaScript. So don't wait for the time to come. Understand the nuances and the basic fundamentals. If you know me very well, when I write on LinkedIn and everywhere I talk, I always talk about fundamental concepts. So what is important about infrastructure engineering and AI is understand what is AI, what does it do, how does it work? That's one. Somebody also talked about AI ops for the first time. What are the operations that will happen in AI? Because at the same time, even in all the stuff we're talking about AI, there's still an infrastructure that is going to run your AI model. You are still going to deploy virtual machines to run your AI model. Your AI model is going to run in a network. It's going to run in a cloud. Amazon launched Amazon Bedrock a couple of months ago. Amazon Bedrock is a combination of different popular models, like the Llama model, like the Cloud Sonnet model, like AWS's model also running in that system. And you also need to understand the infrastructure behind optimizing, scaling, securing, deploying AI models, which is a separate entity of its own. So two things. Number one, you can either pivot and become an AI DevOps cloud engineer, whatever name you want to call it, or you can understand how you can apply AI to your day-to-day work to improve your work to be 10x. So, Okunade, that's exactly where you should focus more on. And hopefully in the coming months, I'll be releasing certain articles about how to navigate some of these nuances.
Thank you very much, Ewere. I'm sure there are a couple of questions in the comment section, and if we are to answer all of those questions, we will not leave this place till 6 p.m. Nigerian time or 10 p.m. Canadian time. So feel free to reach out to Ewere on Medium. He's very active on LinkedIn. He talks sometimes on Twitter. Feel free to connect with him, and I'm sure he would answer all of your questions. I think Ewere's handle is Idiagbonya, but Ewere, feel free to before the end of the day, we'll drop Ewere's Twitter handle. Feel free to connect with Ewere on Twitter and on LinkedIn. He drops lots of insightful stuff on LinkedIn, and I'm sure it would be of great value and benefits to you guys. And for those that still have questions, shoot Ewere a DM. He would answer all of your questions. I'm not guaranteeing you, but
I can just Google my name. I think you can just Google my name. I think that's just Google my name.
C-Flex. Google, just Google his name. You will see.
Just Google my name.
I cannot say. People can see the flex. I can't even say Google my name. You will not see anything.
Yeah, but you need my surname. Just Google my first name and my last name, and you should be good. You should find everything about me. LinkedIn, Medium, Twitter. Just Google my name, Ewere Diagboya, and you should be able to connect with me. Thank you very much for the opportunity and for the time. And over to you, Victor.
Thank you very much, Ewere, once again. It's nice connecting with you and talking to you. Right about now, we are going to our next speaker, and our next speaker is Divine Odazie. He's currently a technology evangelist at several lines. Divine is a developer, relations professional, and a technical writer with 5+ years experience in technology and a track record in backend engineering, DevOps, cloud native, and developer relations on a global scale. Divine has given talks and workshops at developer conferences like Open Source Summit in Europe, KubeCon North America, Cloud Native Rejects, and Ansible Contributor Summit. Divine also supports cloud native communities in Africa, such as the KCD, also known as Kubernetes Community Days. He's the organizer of that. Is in charge of that community and other communities empowering African technology. Divine will be talking about building a flexible and scalable database. Like we did for Ewere. Let's drop the clapping emojis on YouTube as we get Divine up on stage. Let's give him that clapping emoji since we can't clap physically. Thank you very much, guys. Divine, over to you.
Hello everyone and welcome to my talk. In this talk, I'm going to be walking you through building a flexible and scalable database strategy across multiple clouds. A little bit about me. My name is Divine Odazi. I'm a technology evangelist at Several Nines, a company that helps organizations take control of their data by enabling them to do database operations their way. I'm also an electrical electronics engineer and a Kubernetes application developer. I'm also being involved in the data on Kubernetes ecosystem as an ambassador, and I do stuff with AWS as an AWS solution architect. I'm very much excited to speak at this year's Localhost Conference, and thank you for taking your time to listen to my talk. So this is an agenda of how this talk will go. I'll first of all start by discussing what is a multi-cloud database, then look at use cases for multi-cloud database deployment. After that, I'll walk you through a demo on how you can deploy a multi-cloud database. Then, as with all life cycles of application, and particularly database software, database workloads, right? The two operations is very critical beyond deployment. So I'll discuss maintaining a multi-cloud database deployment. So let's get started. So what is multi-cloud, right? Just as the name says, multi-cloud. So it means multiple different clouds. According to the Flexera 2023 report, right, about 89% of enterprises operate some form of multi-cloud environment, right? As my organization, we use multiple clouds too. So I'm a testament to that. Then, what is multi-cloud database? So a database deployment that operates across two or more clouds, right? So a single database deployment that operates across two or more clouds is a multi-cloud database. So now this could be on a public cloud, right? Or a private cloud or hybrid, a mixture of both, right? So a public cloud, right, as we know, is where you share computing resources with other users of the public cloud, whereas private, you have dedicated hardware, dedicated resources, right, just for your particular organization. And every any type of database, right, is a candidate for multiple multi-cloud deployment, right? So relational databases like MySQL, PostgreSQL, right, NoSQL database like MongoDB, Elasticsearch, or key value databases, right, like Redis and Valky, right? And there are some other like databases that are designed distributed for as its initial design, like Yugabyte DB, Cockroach DB, and several other types of databases. So, what are the use cases of multi-cloud databases? The first use case we'll talk about in this talk, right, is disaster recovery. Disaster recovery is by far, right, one of the most common use cases of organization implementing a multi-cloud database, right? According to a report from I think 2 years ago, right, about 96% of organizations experience some form of downtime, right, whether that be to the application in the application layer, their database layer, or wherever in their technology landscape, right? Organizations need to safeguard against major outages because the worst that could happen and actually happen, right? And I don't know if you follow the news. There was a recent report of I think an investment organization, right, losing access to their entire infrastructure on Google Cloud Service, right, GCP, right. I think it was earlier this year, and so that kind of news, right, is the worst that could happen, but it actually happened, right. So organizations need to distribute their workloads, their databases, right, across different environments in order to eliminate single points of failure. Then the next use case is environment optimization, right? So in the case, for example, bringing your database, right, closer to your users, and this will improve performance, this will improve latency, right? Especially in some kind of like application, right, that need performance, right? Mission critical applications, for example. and decrease overhead costs in your ability to get specialty hardware, right, wherever it's cheapest as possible, and also using open source databases, right, and we'll discuss more about that later on in this article. I know, like I mentioned, right, better support for mission critical functionality, just as I think this works in tandem with the data disaster recovery use case we just discussed, right? And also another key aspect of running an organization is cost, right? Especially a software team deploying software, the technology landscape is cost, right? And anyone listening to this talk, you may have had experience with some of the cloud service providers, right? Whether the hyperscalers or the smaller cloud service provider, you know that cost changes over time, right? So the cost, in most cases, the cost that you pay today might not be the cost that you pay in the next 5 years, right? So having one having your database deployed on one particular platform or a managed service, right? It kind of keeps you locked in, right? And you'll not be able to optimize in the future, or you will incur more costs in order to like spread out in the future. Another use case, right, which is very important, is scaling out, right? So you may say that there is no shortage virtual public cloud, right, limitless, but then again there can be shortage of specific instance types, right? And I've seen that in some specific GPU instances, right, for let's say AI specific workloads, right, or some kind of workloads, and also being able to use cheaper option of compute resources, right, when deploying your application, and cheaper also having the benefit of like environment optimization and like that disaster recovery. And another reason, right, in this use case is cloud busting, because some organizations have to be private operate a private cloud, right? Then in some scenario, let's say like a marketing effort or something like happens, right? Cloud busting allows you to like overflow traffic from your private cloud to a public cloud, right? And that is like being able to implement a, a, a multi-cloud database strategy, right? And in the sense that let's say you have replicas on another cloud, right, that takes reads, right? And when there's that scale, right, or let's say a marketing effort, let's say, or an e-commerce platform, and there's Black Friday, for example, or a specific Christmas seasons, for example, you can easily scale out, right, in order to not have downtime, right, and to optimize your databases. Then this is a key use case, right? Control over your data. And just like I highlighted, right, in the previous use cases, organizations need to stay ahead of regulatory changes. In Nigeria, this is, I know most of the listeners in this conference are Nigerians, right? We have our own data law, I say regulatory governing bodies, right? And also, if you go to like Europe, you're trying to enter into the Europe market or other aspects of Africa, you need to be able to have control of your data, right? And if you notice, some governments use some governments here in Nigeria, right, use some specific cloud provider, right? Let's say layer 3 or some other service. And this removes vendor locking in the sense that you can easily move your environment from one cloud service provider to the other, or maybe go on-prem, right? And it removes the need to worry about license changes, right? We all know, follow the news on, okay, Redis changing their license, Elasticsearch is open source again, and all this, right? So all these are not predictable, right? But when you have a kind of like an open source landscape, right, and are not locked into a specific cloud, you can be able to move and have control of your data without worrying about like your footprint and like the effects, right? And today we are seeing the rise of sovereign DBAs, right? Sovereign DBAs is just all I just discussed, being able to take control of your data wherever you want to deploy it and however you want to deploy it, right? And being able to remove and put back in any technology that offers the best support to you. In summary, the goal of every organization is to mitigate risk, right? Ensuring business continuity smoothly without disruption or downtime, right? So all year round, right, you want your users to be able to use your application without worrying about, okay, this service is down at this particular time, right? And that is the goal. Then next, deploying a multi-cloud database, right? So let's talk about that. How can you deploy multi-cloud database? So is deploying and managing a multi-cloud database easy, right? So like that, I know you've just been thinking about it as I was going over the use cases, right? And the short answer is no, right? Because okay, think about microservice architecture, right? It's not easy to build and maintain. How to handle failures of one microservice or the other, right? Let's say you now have your microservice deployed across different clouds, right? Like how do you manage connectivity, secure, reduce latency, and all that, right? And just like with microservices, not all applications should be a microservice, right? The same you can say with multi-cloud database, right? If you don't meet those use cases or have those use cases, right, or require those use cases, right, you shouldn't deploy your application in a multi-cloud way, right? And it depends on your need, right? That is just the summary of it, right? So, but now, how will you do that, right? Let's say if you have that need, how will you do that, right? So you either have to choose between using managed DBAS or versus you building with compute instances, right? The majority of cloud service provider come with some kind of like DBAS, right? So like Azure Cosmos DB, for example, right? The thing is that such solutions are not good in terms with other cloud service provider, right? They don't have that interoperability. Yes, you can do replication, right? But replication focus on data import, right? And not scalability, like seeing the use cases we talked about, right? And there is significant limit in what you can or cannot do, right? So like Aurora, Amazon Aurora, Google Cloud SQL for Postgres. And these are Postgres databases, right? Yes. If you know Postgres, you can use them effectively, right? But then again, they are not open source they are not vanilla open source Postgres, right? I know, like in your experience as an engineer or DevOps engineer, right? You must have heard about the word vanilla. Vanilla being is just as it is, right? Being the core open source project that you find on GitLab, right, or GitHub or any other repository platform, right? So they are not that, they are Amazon's version, Google's version, Aurora's version, let's say DigitalOcean's version, right? With this, hence, when going multi-cloud, you deploy databases with compute instances, right? So building with compute instances gives you greater flexibility for inter-cloud connectivity, right? And it gives you more control of your database configuration, right? And you can leverage the cloud providers tools. Let's say AWS, you have the cloud formation. You can use it to deploy your instances, right? Or you can use Terraform to deploy your instances, right? And leverage other open source software, open source databases, right? In a cloud agnostic setup. So you're not locked in. You don't have to deal with so many like regulations, and there are so many like issues and costs, right, over time, and also in migration. Now the question is, how do you deploy and manage a database across multiple compute instances on different clouds? I know that question is a mouthful, right? But it's a challenge because we all know there's a lot of work after deployments, right? So like I mentioned, day two operations, so backups, right, scaling, right, performing upgrades, right? Security, right, which is like one of the core challenges, right, with cloud services, right? So how will you do that, right? So let's first of all look at the steps to deploy a multi-cloud database, right? So the first step, right, obviously would be to configure cloud credentials, SSH, allow traffic and all, right? Then you need to enable necessary ports, right? SSH, extra backup, let's say in the MySQL space, right? The MySQL specific ports, right, for streaming of data across each node, right, where they be deployed, and also deploy the database on a primary cloud provider, then deploy a VPN for security, right? Then choose a replication type, right? Seeing the example of I'm giving you of MySQL, right? So synchronous or asynchronous, or you want to do both, right? And let's say create more and more replicas, and this is like kind of like a simple setup, right, in your secondary cloud provider. Then you launch a load balancer as a proxy SQL to be able to manage traffic and route traffic among the replicas and the primary node, right? For depending on your user request, and then right deploy monitoring tools like Prometheus, Grafana. So like obviously data operations, you need to know what is going on in your databases, right? So those are the steps that are involved in deploying a multi-cloud database, right? And now how would you like get this step done in the real world, right? So you have a choice to go between manual deployment, right? Do it as manually versus cloud agnostic tooling. And manual deployment, going through that step one at a time, right? For all those steps I talked about, one at a time, right? To deploy your database, configuring backup, replication, installing the database on each instance, right? And connecting each node to the other, right? And for anyone here that have used a DBAS, right, you obviously don't want to do like manual steps, right? And also looking at the looking at the possibility of mistakes, right? It's very error prone, right? On mistakes. And the databases are complex software. They have complex start and end processes, right? And now having a mistake, right, cost money over time, right? Or you lose sensitive data, or you have you didn't configure security where you should configure security, right? So yes, security is a shared responsibility between the cloud provider and you yourself, right? But then again, there are some steps that can help you in order to implement, right, a secured connection, right? So everyone, like most cases, want that DBAS experience, right? But how can you get that DBAS experience without the trade-off of without vendor locking, right? And worrying about regulations and worrying about like cost over time, right? Then we talk about using a cloud agnostic tooling, right? Like cluster control. So cluster control lets you deploy your database softwares, right? Open source and also proprietary databases like MySQL Server that requires some form of specialty license, right? And the only thing you have to really worry about, right, is connectivity between the two clouds. And when I say connectivity between the two clouds, I mean secured connectivity, right? So deploying a VPN and making sure like you have your own your networking engineers in your team have their own traffic rules, right? And how they want to implement connection, right? That's shared responsibility, right? But every other aspect of the database deployment, right? Whether it be the database installation, you're installing Postgres database or MySQL database in the context of this talk, right? Replication across the clouds, replicating of the data, failover, backups, right? And all that aspect is being automated by cloud agnostic tool like cluster control, right? And observability from a start, so you know what is happening on that, giving you kind of a single pane of glass experience, right? So you know, yes, you have your database, you have a single database that is deployed across multiple clouds, right, with several replicas. But then again, you have a single pane of glass, a single interface for you to view it, for you to monitor what's going on, receive alert, and all that. So this is an example of cluster control in work, right? This is an example of cluster control managing a multi-cloud database, right? So as you can see their instances, right? AWS EC2 instances, right? Deployed on an AWS environment, right? Then you have some GCP VMs on Google Cloud. Then you have some on the organization's local data center, right? VMware instances, right? So these are the compute instances, and you have more control over them, right? You can choose to, let's say, replace AWS with Azure or with DigitalOcean. We'll see a short demo briefly, right? So this helps you to move freely and make changes freely and use what is the most cost-effective instance type or instance provider, right, to deploy your application. And now all this, right, the VPN connectivity, let's say using a VPN like Tailscale, right, or the open source version of Tailscale that's built on top WireGuard, right. So this gives you that kind of assurance that you're deploying your databases and you don't have to worry about like errors that's involved in deployment, or worry about the two operations having to deal with that, right. So next, is demo time. So live demo. So we're going to look at a little demo on how you can use cluster control to deploy a multi-cloud database, right? So we're going to deploy a MySQL replication cluster. So with one instance on AWS EC2, right? One node on an AWS EC2 instance and another node on a DigitalOcean droplet. And we see how easy it is for cluster control to replicate data between these two instances and manage the database cluster. Now let's dive deep into the demo. So as you can see here, I have a cluster control environment. I've deployed this cluster control environment on DigitalOcean. So you can deploy cluster control on any cloud provider you want, or you can also deploy on-prem, right, and use it to manage database nodes on any cloud provider and also on-prem. So you can see there's no database cluster deployed in this environment, right? So I've also created a DigitalOcean droplet, the demo DigitalOcean droplet that we'll use for this demo. And you should know the IP address, so 188.166.148.4.1, right? And also created the AWS EC2 instance, and you can note the public IPv4 address of this instance, right? 4422.0.156 164. Why I'm telling you to note this, right? Because I've already established secured connection between cluster control and these two nodes, right? Deployed one on AWS US East, and this one is deployed on AWS US East 1, right, region, and this localhost 2024 DB on DigitalOcean is deployed on DigitalOcean London 1 region, right? And I've established a secured SSH connection, right, that allows cluster control to deploy to install the databases, right, to create the replication and also have all the features to automate all the deployment and life cycle of the database. So next I will go to the cluster control dashboard and click on deploy a cluster, right? So I'm met with two options. So I can also, with cluster control, you can also import an existing database cluster, right? For this demo, I'll create a new database cluster. So yeah, I'll be met with different types of database flavors that I can create, right? So cluster control supports different types of databases and database versions, right? From multiple vendors. So for this demo, I'll be deploying the MySQL replication database flavor. So you can choose between, okay, I want to use the version provided by Percona, right? So this is the open source MySQL database, right? Or Oracle or MariaDB. So I would say MariaDB for this demo. And also the version, right? Cluster control supports several versions of database clusters, right? And this is the latest 11.4 MySQL replication version. Then I'll click continue. Then we'll go to the next step, right? So this gives you kind of the DBAS experience you get on a managed provider, right? So I can name this cluster sovereign sovereign database, sovereign MySQL database, DB cluster. Then I can give it a tag that I want. So let me just say localhost demo. Okay, then continue. Then here I'll have to provide SSH credentials, right? So like I told you, I've already set up SSH connectivity, right? Secure SSH connectivity between the nodes, right? So that allows cluster control to take over the deployment and maintenance of the database. So the SSH user for this demo is a root user, right? Then also you have a choice. Do you want to personally install the database software yourself, right? Do you want to install MySQL yourself, or you want cluster control to do that for you, right? So this is toggled on automatically because in most cases you want cluster control to handle the database installation, right, for you, right? And also security configuration to allow access to the internet to download the necessary open source packages, right? And some of that. You have the control, the choice to toggle this on and off, right? Depending on, let's say, are you using a different kind of binary, right, of the open source database, or you're using a different, like a corporate, your organization version, right, of Postgres that is open source, but like specifically for with your extra security features. So click continue, and there you have the node configuration and all this port already set, right? For demo purposes, let me just say this admin password is test, right? Then encryption enabled, semi-simultaneous replication enabled. You can choose to toggle this on or off. Hovering on each information icon, like each info icon shows you like what this each field means, right? And these are default node configurations. Then now this is the key step, right, where you'll be required to add the node, right? So if you recall from the diagram that I showed, the architectural diagram, this mini architectural diagram, the AWS instance is the primary node, right? So I'll just head over to AWS and copy the public IPv4 address of this AWS instance. In like in production, right, in real world, right, you shouldn't have like this kind of let's say security landscape, in the sense like can easily have anyone can have access to your public IP address, right? So you should implement like a VPN on top, right, and ensure secure access. Then I add it to the primary node, and now once I click add, a see cluster control establish connection, right, to the particular node, right, to verify that okay, it can deploy database instances, right, on this particular node. And we'll just wait a few seconds for cluster control to do that. You see, okay, it turns green, and as with everything, right, green is positive, green is go. So I go and we know that okay, we can move over on this info icon and see this the host details, right? So you can this is a one core CPU node, right, with free memory and is Ubuntu. Then for the replica node, right, so I will just head over to DigitalOcean and copy the uh, IP4 address of the DigitalOcean node, right, and add it in the replica node. And cluster control takes a few seconds to establish connection, and you see this is done, right? So now I click continue, and clicking continue, I can preview this configuration, right? And after previewing it, okay, this is my primary node, and this is my replica node, right? So, and like I showed you, these are on two different cloud providers. Then I click finish, and cluster control creates a job, right, that starts the deployment and creation of the cluster. So you can go and look at this job on the cluster control interface, right? So you can see this job, and you can look at all the details and see as it progresses. I see cluster control checking, okay, is it allowed to deploy? Did you enable it to deploy the database software, right? Or checking the firewall, and those all the configuration. It takes a while because it's a database cluster, right? So it takes a while for this to run, right? And it shows you okay who created this installation, port, and all the necessary spec, right? And you can see the spec. Cluster control also has like a Terraform provider, right? So like your DevOps team and you use Terraform in your workflow, you can just use the Terraform provider without the GUI, like I just showed, right? Also has an API, right? And you can also build on top that API to integrate in your workflow. So however you want to deploy and manage your database clusters, right, in a multi-cloud environment, you get that flexibility. Even Ansible, Puppet, Chef, and all other, let's say, configuration management tooling you would like to use, right? And it takes a few minutes for cluster control to install the software. So while that's been done, let's just look at other aspects of cluster control, right? So cluster control also allows you to create reports, so operational reports. So once the cluster is deployed, we'll be able to select the cluster, right, and create okay database availability report, the backup report, and whatever reports, right, that we want, and send it to a recipient. Also, with cluster control, you don't really need to create like new credentials, right? So if you use an LDAP in your organization, open LDAP, free LDAP, or whatever like Active Directory system you use, right? You can just easily integrate it into cluster control, and all your users can log in with their already existing credentials, right? And this gives you that flexibility and integration that you can get an up and running in cluster control like in less than a few hours or less than a day, right? Depending on your landscape and the amount of users you want to onboard. So let's go and check by the cluster. It's still deploying. And after a few minutes, you see that the cluster will be deployed. It's currently at 99%. And we can just look through the jobs and we see, let's say, scroll, and you see the installing my MySQL system tables, verifying the MySQL installation on each node, and you can see each of the installation process, right, and steps on each node. If like for any reason, right, that the installation fails, the cluster deployment fails at some point, right, there'll be ideally and ideally you want an error message, right? And on this job message messages, right, you'll be able to see an error message and pinpoint, okay, what exactly went wrong, right, in your database cluster installation, and then you debug that. And yeah, so this is how cluster control deploy can help deploy a cluster, right, on any environment that you like. After the cluster is deployed, right, you will see that the cluster is running, I see operational, and monitoring is set up, right? And you can look at each node and you can see the node list. So cluster control automatically a Prometheus, deployed Prometheus, right, in order to collect and display metrics for you. We can see the primary node, writable primary node is the IP address of the AWS EC2 instance, and also you can look at the replica node, and you can look at the node topology, right, and see that okay, this is the primary node and it's replicating data to the replica node. And cluster control goes beyond deployment, right? Shows you database growth over time, allows you to take backups, schedule backups. So you can create a backup on demand, which is a one-off backup, or you can schedule backups periodically. And also alarms, right? Like we receive alerts on actions that perform, right? Maybe CPU usage is high, right? And also jobs where you see that if you create a backup, you're able to see like the backup progress, as I showed you with the cluster installation, and logs, system logs for you to see like MySQL related logs, right? And also audit logs, so that shows you who created what, right, in your database cluster. Reports that I've already talked about. The manage section allows you to make more configuration to your database cluster, and so many other features, right, that cluster control gives you in order to go beyond deployment, but have like allows you to automate the entire database life cycle, right, on any environment. And this single cluster installation, cluster control installation can take up to 500, let's say 300 database nodes, right? So you can deploy Postgres database, MongoDB database, MySQL Calera, and several other database flavors according to you as your organization grows. So that's it, and we'll just head over to the slides and talk about maintenance aspect of multi-cloud database deployments. Now we are done with the demo. Let's look at maintaining a multi-cloud database. So these are the key activities, right, that I've already showed you. Cluster control also offers features to do that, right? So support for monitoring alerts, and also the most important type of alert you need is database specific alerts and an operating system alert, right? Like I mentioned, CPU usage and database health and like replication alerts, because you're replicating data across multiple clouds, right? And also investigating database issues and errors, right? Obviously, it's when investigating issues, the first place to start, right, is with logs, right? And like I showed you, cluster control gives you logs for you to check whether the issue is coming from your system, right, or your database installation, or packages that you may have used, right, in your database installation. Then these are the checklist, right, in best practices in maintaining a database, a multi-cloud database. Like I mentioned, firewall and VPN, right, which you need to obviously is using the cloud is a shared responsibility model. Right? You need to set the right firewalls, allow only the right ports that need access, right, and using a VPN to secure your environment and encrypting data. Also, role-based authentication, like I highlighted, cluster control offers, and scaling, right, the ability to scale up and down, add more nodes, performance, governance, right, which is key in order to properly operate in a country or a state or in a jurisdiction, right? And also backups, like I showed you, and disaster recovery, which is one of the core reasons most organizations go multi-cloud. And some other kind of features that you need, right? Like automated database deployment, right? And bringing DevOps practices and your database deployment together with the use of like Terraform provider, Ansible, and those DevOps tools you already use, right? So this is the end of my talk. So if you want to try out cluster control for free, there is a free forever community version you can try and deploy multi-cloud database clusters or single node database clusters or any type of database cluster beyond MySQL. Just as I showed you, you can scan this QR code. You can send me an email at divine@severanines.com. Also, I'm active on Twitter at _odazie, at _odazie, and on LinkedIn, Divine Odazie, and reach out to me and I can show you more beyond this demo and help you and guide you, and also bring you into the Sovereign DBaaS community to talk more about how you can implement if Sovereign DBaaS in your organization. Thank you very much.
Thank you very, very much, Divine, for that wonderful presentation and demo. There are a few questions. There are a few questions already on YouTube. I can see that Everything DevOps have been able to answer some of them, and yeah, I also know that you are the community lead for Everything DevOps. So I would assume that some of those questions have been answered by you already. But the ones that have not been answered, you could just look through the what's called YouTube and pick at least 3 questions that you believe would benefit every other person here and try to answer them, and we'll just take it up from there. But also, before Divine answers the question, I understand that we mentioned that there's a giveaway at the end of the conference, and it is tied to not just the amount of tweets we put out, but also the quality of the tweets. If you are spamming on Twitter, you will not be selected. Tife, you're already taking the lead. I would advise you maintain the lead without spamming. And that goes to every other person also. For those that are just joining us, welcome. I earlier announced that we have 100K Nigerian Naira to give out to some people on the conference. And how do you get it? You get it by talking about the event on Twitter and on LinkedIn, and how also we also check and monitor those commenting and dropping questions or updates on the YouTube comment section. I have seen 1 or 2 people that are already topping the chat, so I would encourage that we join them and spread the word. I saw someone did something innovative. That person has already won 20K. That I've marked one person that's already taken 20K today on Twitter by virtue of something they shared. So try to be if I tell you what the person did, everybody will do it now. It will defeat the purpose. So let's try to be creative, and yeah, that is so. Divine, over to you.
Yeah, so there are a lot of questions, right, to address. So I think one was when do you think, like, when will you know you need a multi-cloud database deployment? I would say it's skill, right? Depends on your skill, and you won't say you want to, you're just starting to build an application or deploy your product and you're thinking about multi-cloud. Like, you shouldn't even be thinking about microservices, right? So like that is just how to approach it. So it's a certain skill that you get to, right? That you have to like think about, okay, disaster recovery, you have users across different regions, right? And also some regulatory requirements. We will not say they are pertinent to like Nigeria, but like here in Europe, there are a lot of countries that you can't really put data on, like some regions in AWS, right? And like my organization, we work with a lot of people in the Nordics region, Sweden and stuff, right? And France. So we see a lot of those requirements, right? So yeah, so that is an example of like when you know to go multi-cloud. And yeah, then the next question I want to answer it. Someone asked about multi-AZ deployment. So multi-AZ, right? Multiple, which is multiple availability zones. It's basically it's the same region, right? But when we're talking about multi-cloud, we're talking about moving like on different regions, right? Having that like disaster will in order to mitigate for like downtime, right? Issues, and also like I mentioned, regulatory requirements. So it's not something for everyone, but the goal of this talk was to give you an idea, like as those that are already like having these challenges now, and those that are like, getting started to understand like, okay, how can you approach this? How can this be done, right? Without being tied to like a vendor, particular product, and dealing with the long-term cost. Then another question was like, how will multi-cloud affect the cost of data storage, egress, and management across providers, right? So I think that is the major thing, because like cost is like one of the major reasons. But if you look at the long-term talk, I'm planning on giving a talk before the end of the year, right? The long-term cost on DBAs or managed DBAs and like sovereign DBAs, right? You know, I kept mentioning sovereign DBAs having like that flexibility to move across like platforms and cloud and on-prem. So if you look at it, right, the long-term cost, yeah, if you can just spin up RDS or Aurora with like in a sec, right, and like do basic like you pay as you go model, right? But if you look at the long-term cost and management, hence I talked about cloud agnostic tooling that helps you simplify the management, right? So you won't have to like be manually going into the cloud providers on its own, right? Once you've already spin up the instances. On a programmatic aspect, you can use Terraform and spin up the instances, right? And make those connections. So you can put everything like in a script using Terraform and Ansible, which like cluster control as a tool supports that, right? So yeah, so I hope that gives you an idea on how like to manage and like then egress, right, and traffic and all depends on your security rules, right? And they have to properly think about that, right? And the next question, I think that would be is almost time for me. It's time already. That would be last question. So how does cluster control function as that of Kubernetes? So cluster control can be deployed on Kubernetes, right? And like for you to for kind of be deployed on Kubernetes for you to manage your databases, right? But this current version is to manage your databases on VMs or bare metal on-prem, right? So, but we are currently working on towards helping organizations deploy for cluster control to manage operators on Kubernetes, right? Manage databases deployed on Kubernetes. So now, like I can share in the chats right now, like there's a Helm chat you can just download, right, and install cluster control on Kubernetes. Well, it all depends on if you're really using Kubernetes on a day-to-day. So you shouldn't be worrying about Kubernetes if you like have not reached a certain scale and have a need for Kubernetes, right? So yeah.
Thank you very much, Divine, for those wonderful answers and insights. Guys, feel free to reach out to Divine. He had dropped his socials. You can also follow him on Twitter. His handle is _Odazie, right?
Yeah, Odazie. You can just search Divine Odazie. I'm not as big as Serere, but if you search Divine Odazie, you go find me one or two places. Make I start I see a start live. Make I know they drag with my bone. But yeah. So
Okay,
you can
feel
just
free
like
to
see
reach
all
out
my
to.
profiles. Yeah, and I'm active on LinkedIn. I always accept all connection requests and all.
Okay,
Yeah.
thank you very much, Divine. Feel free to reach out to Divine. Also follow everything DevOps on Twitter I think that they're also doing good stuff there. Yeah, he had also answered a couple of questions on YouTube. So do well to like and subscribe to his YouTube page. And yeah, also, guys, I would suggest that we all go to the YouTube live stream and like the video and possibly share the video. It helps with algorithm and also helps with pushing or suggesting and recommending this YouTube video to other people that might be interested but don't know about the events. So do well to share, like, and subscribe. See me sounding like a YouTube influencer.
Subscribe, bro, subscribe.
Okay.
They are tired, I know. All right, thanks for having me.
Yeah, thank you. Okay, yeah. Also, some of us got emails about joining breakout session. Please look through the emails that was shared and confirm the breakout sessions you would be interested in. We have a deep dive into monitoring, and we have multi-tenancy in Kubernetes. If you're interested in joining the first session, you should fill a form that was sent to you on the email, and you'll get an invite on where you would join the session, while the other session would happen on this live stream. But both sessions would be recorded, so you will not be missing too much, because if you join one session, you get to watch the other session later. So go through, check the email that was sent to you for the invite to this conference, and pick a breakout session that you would be interested in. Thank you very much. So I think if you look through the comment section, Localhost just shared a form where you can indicate interest if you want to join the deep dive into monitoring breakout session. Do well to check that out. We are ready for our next speaker, Alaye Somi Femi. He is currently the lead platform engineer at Mono. He is a software engineer with a focus on backend engineering and cloud engineering. Femi has been in the payment industry for over 5 years, building and leading technical teams. He's been a certified AWS developer associate. He's an advocate for scalable and optimized system while building on the cloud. Femi also enjoys learning, knowledge sharing, and providing mentorship with his experience whenever, wherever, and however he can. And Femi would be talking about optimizing serverless apps, the how and the why, like we've always done with an emoji of applause. Let's welcome Femi to the podium. Femi, run. Femi, you can unmute your mic.
Hi everyone. Can everyone just confirm you can hear me?
I can hear you now, Femi.
I really appreciate that. All right, cool. Okay, yeah. I'm Femi. All right. I'm Femi, and currently a backend engineering lead at Mono. Brief about me: I'm also like a certified developer, associate AWS. Okay, can everyone hear me? I was getting a feedback. Just confirm. All right. So I'll just go on. So today I'll be talking to us on optimizing serverless applications, the why and the how, right? So basically, what are serverless applications, right? Serverless applications are not new. You know, they are simply applications running on a third party or fully managed resource on the cloud, thereby allowing developers to focus completely on the business logic of an application without managing servers, and where their code runs. If you've worked in a traditional software industry back in, say, maybe like 5 years ago, you would see how it's like a hassle when it comes to managing servers. It can be a headache, right? And so basically serverless applications, they are not new, they've been around for a while, and the goal is basically to to take the hassle, away from engineers to manage servers, right? So the goal for that is to ensure that engineers can just focus on the business logic and add value to the business without worrying about where their code runs, right? So now the big question, why serverless? Why do people lean towards building applications with the serverless architecture, right? One primary benefit of that is that the serverless architecture is taking away the effort and the responsibility of infrastructure management away from engineers, right? And these responsibilities from networking to resource provisioning to server maintenance and including scaling as well. And then here I just listed a couple of interesting benefits that comes with building on with serverless architecture, right? Number one is cost efficiency, right? Because you don't get to acquire so much servers, but you just get to pay as you go, right? You just get to pay for exactly what you're using on the cloud, right? Like at that point where your application or where your functions are being triggered, that is when you get billed, and then also there's reduced operational management or cost, right? Because at the end of the day, if you are running an application or you are building where you get to provision servers, where you get to provision where your application runs and stuff like that, you find out that you maybe have to have a personnel to manage those servers, or you maybe get to have, if you're not on the cloud as well, you maybe have to have a server room, to manage where those servers run, and we've gone way, way, way past building softwares that way. So today, this is one advantage that comes with building with serverless architectures. Another one is elastic scalability, right? So it's easy for you to scale, based on more workload, right? And also downscale when when you have less workloads, right? So take for an instance when I think most of the people that have been talking, they've been talking about shopping carts. I also use that example. So take when maybe you are running a sales, maybe a Black Friday sales, for example, you realize that you have so much traffic at that time, right? Now, the idea would be that you don't get to worry about provisioning more servers, building with a serverless architecture, you have that already if you have that configured as well, of course, you can easily scale up or scale down based on the workload or the traffic you're having at that time, right? Another one is faster feature release, because it's easy, to easily deploy these functions or these serverless functions, you can fully focus on just building individual business logics, and then it's easy for you to go to market faster. And then another one is improved reliability. Your software is these cloud vendors, like AWS. I'm trying to make sure that this talk is not centered on a particular vendor, AWS or cloud or GCP, as the case may be. So these guys have built-in fault tolerance for your application, so that you don't get to experience downtime at all, or even often, and then there's also faster development cycles, because just like you have reduced operational management and then faster feature releases, the development cycle also reduces, because you are basically building faster, and then it's easier for you to also scale as well. So some common platform as a service vendors for serverless application, like I mentioned earlier, AWS, GCP on Microsoft Azure Functions, and then Vessel as well also provides, services that you can leverage to build serverless applications, right? So this is just a brief architectural diagram of how a serverless application would be structured. So you could have, say for example, you are building an e-commerce platform, right? and you have your clients that points to your API gateway, and then you have about 3 serverless functions here that are doing individual thing within your ecosystem, right? So it's easier for you to like maybe write a module to manage file upload, you know, another module to manage payments, another module to manage adding products to cart and all those stuff, you know. So this is, and it's really direct and it's really easier for you to manage, you know, because you know which function is doing what at every particular point in time, right? So also, basically, I'll just give a brief explanation of how serverless functions actually work, you know, and also it's good for us to bear in mind that serverless functions, they can easily be they can either be triggered synchronously or asynchronously, and I'll talk more about how it's best, you know, to build with serverless functions. But let's just dive into just like a brief explanation of how it actually works. And then, because I believe strongly well that if you know how it works, if you understand the basics, then it becomes easier for you to optimize, you know, because when you understand how it works, then you know where and how and what exactly you are going to optimize to make your application work better, you know, when you are building with serverless within the serverless architecture, right? So of course they can be triggered in 2 ways, you know, through synchronous calls, either through API calls, you know, having like an API gateway that points to them, and then you get your request and response immediately, just like the conventional API, you know, and then when those API calls come in, they can trigger your serverless application, your serverless functions, and then your serverless functions, of course, they are language agnostics. You can have Node.js or Python or Go or whatever language that the case may be. And that's where your code runs. And then you have the execution environment, which is provisioned for executing like your code when your functions get triggered. And then you have your compute substrate, which is basically like the underlying computation engine where your environments are provisioned, right, when your function is triggered, right? Now, so I just gave a brief code snippet on how you would structure your serverless function, you know, your code to work for your serverless function, right? And then, like I said, the second way they could be triggered is through asynchronous or event triggers, right? So you could have and also this is like the best way for you to actually build with a serverless architecture, right? Because that way you know that your application gets triggered and then you don't get to wait for your response, you know, when it's done, you know, and that way it's more fault tolerance. You can manage retries when something goes wrong because everything is asynchronous, and then maybe those results are maybe sent through a WebSocket, or maybe there's a polling engine that is polling that result at the end of the day, right? So that's like basically a brief high level explanation of how your serverless functions work, right? So in this talk, I'll basically be talking about 3 major optimization metrics, since we've talked about how it works, you know, and then we understand why organizations, or why we should actually be building with serverless functions these days. You know, I'll be talking about 3 key optimization metrics that we should consider when building with a serverless architecture, right? So number 1 is latency. Number 2 is cost. Of course, when you're building on the cloud, one thing you should be thinking of is how to optimize cost to ensure that your organization is not paying more than expected when things could be done better, and then your organizations could enjoy the benefits of building on the cloud better. You know, and then number 3 is throughput, right? That's how much data your application can process at every given point in time. And then latency is how much it takes for your application to respond after it gets triggered for a particular request, right? So 3 areas we'll be considering for optimization are code start, memory and CPU tuning, and then also like monitoring and logging, right? These are like 3 major aspects of optimizations we'll be considering in this talk. All right, so let's just dive into what cold starts are. So cold starts are, it's basically the boot time it takes for your serverless function to be invoked, right? So for the first time, or when it scales up. So cold start is basically, say your function gets triggered, right? The time it takes for your function to load up, because it's basically like your function is in idle state, right? If it's not being used at every point in time, if it's not frequently used, basically. So the first time it gets triggered, or the first time your application scales up to respond to the workload that is coming in, you have a cold start, right? Because cold start is basically how much time it takes, for your serverless function to boot up to respond to that request that you sent, right? And cold start can be very expensive. If you think of it, imagine if you need to send a request to your application, and then you get to wait till it loads up all dependencies, and then when that is done, that is when it then executes that particular request, and that's really expensive, right? And that's why I mentioned earlier that it's really good to build, when you're using the serverless architecture, it's good to also always think of how you can manage requests asynchronously, right? Because of things like this, right? It can be really expensive as they affect the cost of utilization and latency of serverless application. With a serverless function, there is no mechanism to target warm environment. So basically, warm environment is an environment that has already loaded those dependencies. The downside is there is really no way to target only warm environments. That's like, you don't want to always load up a new environment when you want to respond to a request. But there are ways to optimize your application so that it reduces the time for a cold start to happen to respond to a particular request, which is what we'll be talking about in the next slides. It's important. It's also very important to deliberately reduce and eliminate cold start, regardless of how often a function is invoked in a serverless architecture, right? Like I said, a warm environment would be like, say you have a function that, let's say, that processes payments, for example, in your application, right? Of course, that particular function will be triggered very often, right? Compared to a function that, say, now I'm talking in the scope of like an e-commerce platform, right? Compared to a section of your platform that, say, maybe handles file upload. File upload would be triggered, especially when people just want to, upload products, and that part of the section that function wouldn't be as triggered as often as it would be, as the payments function will be triggered, because that's where you actually collect money. So think of it in this way: your payments module would have a warm environment for most of the time, but compared to your file upload, you would have a lot of cold starts in that on that function. Therefore, you need to think of you need to like consider better ways that you want to optimize, cold start in that part of your architecture, right? So now, eliminating cold start. Now, since we've established a problem, that one major problem is cold start, when you are building serverless applications. Now, how do we eliminate or reduce, cold start? Number one is, right, optimize dependency initialization. Right now, how do you optimize this dependency initialization? We'll talk about that in another slide, because this is really, really broad, when it comes to managing your serverless functions, right? Now, it means you don't want to like always load up or always initialize dependencies every point in time when you are invoking your functions. You want to reuse these dependencies. For example, node modules, for guys that write Node.js, or you will see that node modules are really, there was this meme I see online where you have several people running into a particular place. That's how it works when you're installing node modules. You have several dependencies. You have dependencies that have dependencies. You have those other, so it's like a nested dependency stuff, right? And it's a lot of hassle when you get to, imagine you have to do npm install every time you want to invoke or collect payments from your customers. That's terrible, right? So it's really important for you to manage those dependencies effectively. Basically, like to reuse dependencies every time your application is your functions are invoked. Another thing is reusing network or database connections, right? So, and this is one major mistake that folks make, when they are building serverless application, because it's basically trigger call is something like, I'm sleeping, call me, use me, dump me, call me, use me, dump me, basically that kind of stuff, right? You want to always reuse existing network or database connections that you already established, right? And then you also have ahead of time code compilation, right? You don't want to be compiling your code at the time when your functions get triggered, right? So you want to compile your code ahead of time and then bundle them up and deploy, right? That's the effective way to do that. And you can easily do this, or you can easily do this having like an effective CI/CD pipeline. Of course, you can have a CI/CD pipeline to manage building your code, compiling your code ahead of time and then deploying the binary or compiled files. That's how it should work. Not you having to deploy, and then having to compile at the time of when your function is initialized or triggered, right? Also another thing is that when you're building with the serverless architecture, it's important to build with languages that handle concurrent requests optimally, with less memory allocation, right? To be honest, serverless functions don't, like, there is really no like underlying way to effectively manage concurrent requests, because all requests are managed sequentially, right? It's not like you have the same environment managing 10 requests at the same time. No, it is when a request comes in, it handles that request. When another request comes in, handle that request like that. But what you can do is that these requests that come in, they don't get to initialize dependencies. This request meets basically like a warm environment, and then they can use existing connections or existing dependencies and then handle that request effectively. And then when you're building with this, you want to make sure that you're not building with, no offense to Java engineers, but you're not building with things like Java, where you have so much garbage collection, you have several, memory allocation when it comes to handling just a simple request. You want to build it languages that handle that, that are built to extensively to handle that better. Languages like Node.js, Go, Python, those kind of languages would best be suited for a serverless architecture. Also, there's something that AWS does. It's provision concurrency for resources required for your serverless application. So it's basically like ahead, like providing extra resources for you ahead of time. Basically, instead of you having to scale up when you have more workload, basically you have more resources already allocated, and then you can easily use those resources when you want to scale up. So those are like 5 interesting ways that you can reduce or eliminate cold starts, right? Now, I said in the previous slide that we need to optimize optimized dependency initialization. So now, how do we do that, right? Number one is import only what you need, right? Import only what you need, right? Only use what you need. Simple, right? Say you have a library that exposes several APIs, right? For example, in this slide, I'm talking about, I imported here MongoDB, for example, right? This library has several APIs. There's the Mongo client, there's several things. There are how to manage connections, how to close the connections that is exposed from this library, right? There is no point importing the entire library in this particular function, right? It's really terrible. It's a terrible way of of using dependencies. And this even goes outside of the scope of serverless. It also goes on when you are building, your applications, right? So import only what you need. Keep it small and simple, right? If you notice in the previous slide, I showed an architecture of a serverless architecture that had, the payments module, the file upload module, those were separated. You don't want to chunk up things in one function doing several things. It doesn't make any sense. It's good for you to split things up, keep them clean, keep them separated and simple, right? And then use layers to load external dependencies, right? You also want to ensure that you have layers so that these node modules that, or these dependencies that are required by maybe three, four functions, they can be shared, across these functions, right? That's what layers does for you. So they can be shared across these functions, and then you can easily manage these dependencies, right? Another thing is abstract network and database connections, right? If you notice here, here in this slide, you'll notice that we are reusing, we are abstracting, we are removing away how we connect to the Mongo client, and then we are reusing that same connection every point in time when this function is invoked, right? Actually, what gets called, this is AWS Lambda, to be just for reference purpose. This is how it's written. This is how you structure your code to be written when you're working with Lambda functions. But the whole essence is what gets triggered is the handler function, right? So if you see here, we abstracted away the Mongo client, and so that we can always reuse that same connection when the handler function gets triggered, right? Now, reuse database connection. I think I already spoke about that in the previous comment as well. So reuse database connections. You don't want to always initialize a connection every point in time when your serverless functions are invoked. It doesn't make any sense, right? All right. So moving on, memory and CPU tuning. Now, serverless functions are built by how much execution time it takes for each execution, right? So you are built for how much time it takes for you to execute for you to execute a request, right? Thereby optimizing and tuning the allocated resources for the function is necessary based on the workload. Increasing memory allocation for serverless function improves the cost of utilization and latency. It does. To be honest, I'll show us like a small experiment I did with with different memory allocations, and then how much time it took, and then use with the same workload, right? You realize that your network, like how much resources you allocate to your functions, right? It can either take more time or it can take less time. And the goal is to make sure that it takes less time so you pay small, so you don't get to pay so much when you can actually pay less, for executing a particular no. However, achieving the most suitable memory and CPU for serverless functions requires some analysis over time, right? So to be honest, there is really no cast in stone way of doing it, right? You need to, and optimization has to be a culture, when it comes to DevOps. It has to be our culture. Like, it has to be part of what you do. It has to be like a weekly task, what are we optimizing? What are we doing better? What can we do better? And then achieving like the suitable memory or CPU for your serverless functions requires some analysis over time, because as your business grows, you have more users, you have more requests, you have more features, you have more aspects of your system that invites more requests. So you need to make sure that your analysis is a continuous process, right? Okay. Now, so here we just give a brief example of how memory tuning, like how we did a memory tuning to achieve like the best results. Now, if you see here, it's a very simple. I just did a simple experiment with logging hello world to function 1 million times, basically, right? And then I did it on AWS. I used Lambda with that processor and in Africa, Cape Town region, right? So first I had 120 MB, right? It took 15 seconds, a lot of time, and then that was the cost for that, right? But if you see the memory, when I looked at about 2 gig, it took about 1 second, and I paid less, for that particular call. So this is something that has to happen over time for you to get the best memory you need to allocate to your function, right? Now the last part, it would be memory and logging, right? Of course, observability is key when you are building any application. any application, and that's includes serverless applications as well. And then this is available and achievable on most serverless or cloud vendors, including AWS, GCP, etc. For example, on AWS, you have CloudWatch, you have X-Ray, which is helpful for observability and getting insights on what needs to be optimized for AWS Lambda functions, right? And then this is just like a brief diagram of X-Ray in action, right? Here you have two serverless functions. You have an API gateway. When the request comes in, you can see how long it took, like the life cycle of the request from start to finish. Now here you can say, okay, it seems our serverless function B is taking so much time, right? What can we optimize? Memory, or we can allocate more space, or is it the code that we need to optimize, or is it how we reuse the the database connection? Tools like this help to see what is actually going on in your serverless application, right? And this can easily be utilized by these cloud vendors, right? So yeah, do it right or do it twice, right? That's the slogan that's my slogan for optimization, my personal slogan. Do it right or you go back and do it twice, right? Optimize dependency imports, right? So in this only import or use what you need, right? Also keep your serverless functions small. Single responsibility if possible, right? Single responsibility if possible. I'm a big fan of or I'm a big preacher, let me put it that way, of this, right? If you are not going to, if you are going to have your serverless functions do more than one thing, yeah, I think that's like a bad idea, right? Let it do, or if it's going to do more than one, these two things should be related, right? They shouldn't be like you are doing file upload in the same function. You're also doing payments in the same function. You're also handling how you delete users or how you log users in the same. That is ridiculous, right? It's better you make sure that these things are properly separated, right? Employ external orchestration to avoid long-running idle operations, right? Now, external orchestration is something, an example is AWS step functions, right? When you have long-running idle operations, you are just going to pay for that long-running idle operations, right? And you don't want that to happen. And a better way to do that, to help do that, is having things like AWS step functions to manage when your function, what happens next when your function is done, like to properly manage that. That's when you have like an async process, of course, that is running, right? You want to manage that kind of the life cycle of those functions being called with step functions, or what happens next when a particular execution is done. Now, pay quality attention to resource allocation. Yeah, pay quality attention to is something that engineers or even DevOps engineers also like. Sometimes, DevOps engineers are, sometimes forget. Even when building, right? Pay quality attention to resource allocation, reuse external connections, and use serverless functions more for asynchronous processes, right? So these 6 points, right? Hold them and put them at the back of your mind when you are building serverless applications. If not, you pay more, or you just find out that you are not actually utilizing the benefits of you building with the serverless approach. All right, so now I'll just take questions on the talk.
Femi. Thank you very much. Thank you very, very much, Femi. I'm trying to look through the YouTube comment section for questions. I think aren't there languages that have features that handle concurrency and multi-threading? That's one question from Avalumun Yengede. Yeah, it's on the screen.
Aren't there languages that have features that handle concurrency and of course they are. But my point, the point here is you also want to ensure that you are building serverless applications with these languages, and then you also want to ensure that you are not using so much resources, when you are building on serverless. Because if you are using so much resources, you realize that your application is taking so long and you are using so much. Meanwhile, you could build with something very light, like maybe JavaScript. Maybe you could use JavaScript or Go to achieve this same thing, and you go and carry Java, and you want to build, and you want to put it on a Lambda function. That's so much, right? You will realize that you are allocating more resources to a simple task that you could have executed when you are building with languages like the one I mentioned. Does that answer your question?
I'm sure. I'm sure it does. The next question is also on the screen. What are the processes involved in fine-tuning your serverless workload for selecting the right CPU and memory? What sort of tests should be done and how?
Okay. What are the processes involved in fine-tuning your serverless workload? What sort of tests should be done and how? Okay, like I said, it's a continuous process, right? It's not cast in stone, right? It's something that you should do over time, right? And now, number one is, if you're going to test, there are tools, that can help test. There's a couple of open source tools that can help you do that. And then also there are some of these tools that you can actually build internally, to stress test your application, and see the performance, over time. If you are building maybe like an application that is that maybe you don't have users yet and you want to stress test, of course, that just like the example I gave, I was basically logging hello world, 1 million times. That's the stress test, right? I'm basically seeing the performance with this range and then seeing which one works best for my application, and then also if you have users, that's even an interesting way. If you already have users already, you know that, okay, and this is if you don't want to do like auto scaling so that your platform can easily scale up or scale down based on workloads are coming. This is if you want to manage that by yourself, and then you can easily like experiment over time and see how well your system would perform with different workloads, and like I said, it has to be like a culture for your DevOps team and for your engineering team in general, right? It's not like something that you do once a year. No, it's something that you have to do continuously, as the business grows. Does that address your question? Emani. Yeah, Emani.
Yeah, I'm sure. I'm sure it did answer his or her question.
All right.
One question I saw earlier was someone was saying, the same way you are campaigning and you are talking about the advantages of serverless. Can you also highlight some other disadvantages of serverless infrastructure architecture?
Oh yeah, definitely. Everything that has a good side has a bad side, right? So one of the downsides would be, like I said, if you don't manage your dependencies correctly, you pay for it. If you are not working with people that are experienced, on your team, you would pay for it. You would pay for it at the end of the day, because you would have processes that are long running, and then you'll be running Netasketa to find out where or what is causing us to pay more. And then that could be like a Lambda functions that is running on its own, that's running the process continuously. Another downside would be it basically forces you on a way to structure your code. You have to structure your code in the way the cloud vendor or the cloud provider wants you to structure your code. Like those code snippet I shared earlier, you would see exports.handler. If you're a guy that doesn't like, having just functions to run your stuff, and you want to have classes and those kind of OOP on your platform, yeah, serverless would force you, to structure your code in a particular way. So I mean, if that would be a downside for your team, yeah, that's also another downside with building with serverless. But the good side of it is when you build with this approach, you don't get to worry about managing servers, and that's interesting. That's really cool. You don't get and this is especially when you want to quickly go to market. You want to quickly build stuff. Or you want to handle a particular asynchronous process of your large enterprise platform to manage that effectively asynchronously, and you could go for the serverless approach, right?
So I have one question. Yeah, why you spoke about trying to build fast, you should go serverless. What happens if you are also trying to scale? I'll assume, yeah, you built and you want to go to market as quickly as possible, but there's also need to scale your application as the application grows. How would you advise that engineers handle scale as regards serverless infrastructure?
Yeah, like honestly, when it comes to scaling, there are several aspects when it comes to scaling. There is maybe you are having more data, and then you have to expand maybe the database level of your application, or if it's the actual application itself, you need more resources. You can still achieve that with the serverless approach. Definitely, you can still achieve that, but you have to make sure that your functions are not doing more than they should be doing, right? You should make sure that you structure. Like I mentioned in one of my slides, you want to make sure that one function is not doing 10 things. That's really ridiculous, right? And I've seen people do this, right? One function is doing several things. Let's say maybe you are building, say, like a what do they call this application? Like maybe like an investment platform, for example, right? And then this investment platform, people get to trade. You want to have one function that is maybe getting currency pairs. You also have one function that people actually use that gets called when people want to like execute a trade. It should be properly modularized, right? And then this serverless, these guys can also scale automatically too. It's something that you can still use if you want to like build for a large scale, product. You can still use it, but you need to make sure that your application is properly optimized, so you don't get to pay for more than you should be paying for on the cloud, basically.
Thank you very much, Femi. How do people get to? I'm sure some people will have follow-up questions. I would want to connect with you. Are you active on LinkedIn, on Twitter?
Oh, yeah. You can just. I'm not like a weary. I'm not.
Where is not the benchmark?
Where is the chairman on LinkedIn and Twitter? But yeah, you can follow me on Twitter, and that's my GitHub as well. My Twitter handle, Alaisomi, my surname. Or you can search me on Google, Femi Alaisomi. Yeah.
Thank you.
Feel free to follow me on LinkedIn as well. I'll definitely. I'm quite active on LinkedIn and Twitter as well. Yeah.
Thank you very, very much, Femi, for your time. We really do appreciate you. Thank you very much. Right. Hey guys, we still have people online. Kindly check your emails because we're about to start the breakout session in a minute or two. If you've not gotten the link to this second breakout session, kindly drop a comment on YouTube and we will look at it immediately. And also, if you've gotten an email or a URL to the link for your breakout session, kindly indicate by saying yes something in the YouTube comment section. Thanks, guys. If you are just joining us, welcome to Localhost Conference 2024. If you are just joining us also, please drop a flag of where you are or where you are joining us from, because we've seen people join us from the UK, from Hong Kong, from the US, Canada. I think I saw Italy some time ago. So yeah. So feel free to drop a flag or tell us where you are listening from if you are just joining us. and if you've been with us since, thanks for still being here. We appreciate your time and we don't take it for granted. Yeah, it seems like everyone has gotten their email to join the breakout session. So yeah, we can, for those of us that are in the other breakout session, we can see somebody also joining from Guinea West. Welcome, Mohammed. Welcome, Martina. If you are not on this breakout, feel free to join the other breakout session because I'm sure the speaker is waiting for you there. If you are joining us here also, you can stay while I would also introduce Alex that would be taking us through this session. So if you are for deep dive into monitoring, you should join the other breakout session. I think the speaker is also waiting for you there. While if you are for us here, you can stay here. I think somebody was asking if there is I'm sure there's a Slack channel. I don't know if there's a Discord, but I would confirm before the end of the day. We would share URLs to our socials where you can connect and get all of the information. Michael Olamilekon, feel free to click on the URL Localhost just shared. Hold on, let me see. I'm going to copy it now and paste it for you. Yeah, I just dropped the URL to join this session. Favor, kindly help with the form where they would click to indicate interest on the comment on the YouTube session. Yeah, Hazel, the recording will be available on YouTube. So you will not be missing anything if you choose here or you choose the other breakout session. You get to enjoy both anyways. But yeah, for now you have to pick your area of interest and join. So yeah, I think the form is pinned. For those that have not seen the form is pinned on the chart. Just scroll to the top part of the chart. You'd see localhost, right? Rows indicate interest for monitoring here. Okay, I think some other people have already started joining the other breakout session. So I think we can introduce Alex and we can start. Alex is an experienced software engineer who is passionate about the cloud tech innovation. Since 2011, he has been immersed in diverse tech projects, excelling in complex architectures, problem solving, and leading teams across various industries. Beyond work, Alex engages in R&D, pushing boundaries and exploring new ideas. Alex believes firmly in open source knowledge sharing for collective progress. Eager to contribute to the community, Alex aims for the future with unhindered technological advancement, building a brighter and more innovative world. With an emoji of applause, like we always do, kindly welcome Alex to the podium. For those asking for the link is pinned in the comments. For those asking for a link to the other session, it is pinned in the comments section. Feel free to join the other breakout session. Yeah, so Alex, over to you.
All right. Good afternoon, everyone. My name is Alex Liu, CTO at PipeOps, and today I will be speaking on multi-tenancy in Kubernetes. So just give me a moment, let me pull up my screen for this quickly. All right. So yeah, I think I can get started. So yeah, today I'll be speaking on multi-tenancy in Kubernetes. So before I get started, I believe we've all had that moment where we feel like it would be better to share a single cluster rather than manage multiple clusters at once. At PipeOps, we do come across like different companies at their various stage doing different things, right? Either wrongly or rightly. And one thing we've noticed is that you see people setting up like, you see a startup who's still probably trying to launch a stable product, and you see them using like 3 Kubernetes clusters, or maybe even 2 Kubernetes clusters, just because you want to, adhere to some compliance level or whatever, right? And there've been cases where you've thought about sharing the single Kubernetes clusters within your team, within different departments, to even further save cost and save management overhead. So we'll quickly dive deeper into what multi-tenancy is in Kubernetes, types of the multi-tenancy models, and I've provided a short script that we can use to test out like different examples and tools that we can use to achieve this. So yeah, multi-tenancy in Kubernetes is sharing a single cluster among multiple users, teams, or application while maintaining isolation and security. So take for example now, right? So imagine I'm the let's say organizer of Localhost, and I want to share cluster with everyone, right? On this conference. Let's just say in this conference, for example, or let's use the department that various people currently operate on or operate at during the course of organizing the Localhost event. So take for example now, let's say the media team, right? They need to have their own sort of clusters, right? And they need to be able to operate, right? Do like without ever having to depend on me, similar to them having their own setup in some ways, right? I can spin up a single Kubernetes cluster, share with the media team, share with the technical team, share with the marketing team, right? To do whatever they want to do, or to deploy whatever they need to deploy as well. So we'll take a look and dive deeper into what this looks like. Why multi-tenancy in Kubernetes, right? Just like I said earlier on, the fact that managing a single cluster, can consolidate infrastructure and administrative overhead, right? This can also lead to significant cost. Imagine managing 3 clusters or maybe even 4 clusters, and you have just one DevOps engineer to do that, right? So obviously there will be mistakes, right? So the more clusters you have, the more DevOps engineers you need to bring into your organization to manage those infrastructures for you. And then the next one is managing multiple development teams on a single cluster, just like I illustrated with Localhost, and then supporting various projects on a single cluster, balancing resource allocation in a growing organization. So we can use these multi-tenancy strategies in all these various aspects just to further save cost and be able to maximize the little we have, basically. And we'll see what that looks like shortly as we proceed. So yeah, moving on to the types of multi-tenancy in Kubernetes. We have the soft multi-tenancy, which provides logical separation with reduced isolation. And I will break that down to us. So take for example now, if I want to implement multi-tenancy in Kubernetes natively without using any tool, right? I would pick up a namespace, right? Create a namespace. I'm going to say I want each namespace to identify a tenant, right? Set up network policies, right? Set up the necessary additional tools. Maybe I want to use OPA for policy management or governance of the cluster, right? Configure every necessary features I need to configure to logically separate each tenant. Now that's me implementing it manually, right, on my own. And this gives us little isolation, cause you're just sharing namespaces with users. So that means every user, everyone who is a tenant of that particular cluster is prone to whatever problems happens or go on in that entire cluster itself. It means everyone is sharing the same node itself, and everyone is sharing the same life cycle, the same SLA of that particular cluster itself. And so just to go over this, we use namespace and network space to isolate. Resource can be shared even more efficiently between tenants. Generally, it is more cost effective, but has like potential security concerns. We'll look at these security concerns in more details on some of my slides. And then this also requires careful configuration to ensure proper isolation and resource allocation. So take for instance now, if you're not careful as to how you set resource, how you limit resource, and how you like allocate resource to this tenant, a lot could go wrong. A practical example to this was when we launched our first version of our developer plan that was based on multi-tenancy in Kubernetes, implemented, like completely implemented by us behind the scene. And we ran into a lot of issues at the very first stage of building this. I think this was around like early 2021 when I was like still working on the first version then. We ran into a lot of issues, and then we had to go back to the board. You have to be careful with the name, with how you choose, with the naming pattern, basically the naming convention. You need to be careful on the kind of naming convention you choose, because there are like problems that are still native to the cluster itself that can carry over to any tenant you create, even if they all have their own kubeconfig file. So take for example now, if I set up a custom CRD on the cluster, right? Each tenant can also do that on their own, right? So, and also if I have, let's say multiple tenants have like admin access to the same Kubernetes cluster, it means they're also able to get like administrative privilege over that cluster, be able to, get access to maybe some, let's say, custom resource that are defined in the cluster, for example, even Helm chart as well. So that's one of the disadvantages of sharing, of using the soft multi-tenancy approach. So moving on to the next type of tenancy approach in Kubernetes is the hard multi-tenancy. And now, this is a bit different from the soft multi-tenancy, because the first stage to it is we can go through the typical idea approach of, hey, I want to set up an infra, right? You set up an isolated infra for each user on their own individual AWS account. Now, that's the first part. We also have the virtual cluster, right? And then there is the third part where we can deploy like a proxy, right? Like a proxy that serves as a proxy to our underlying Kubernetes API proxy itself. And I'll show us tools that we can use to do this. So moving on with the hard tenancy, this provides stronger isolation. Each tenant typically has their own separate Kubernetes cluster. Either it is a virtual cluster or it is its own cluster in its individual cloud provider, or set up using KTS or something else, right? It also offers better security and compliance as tenants are like, completely isolated. So everyone is no longer deploying to like a single node right now, and everyone is not exactly in. It depends on the models you are even using in the hard tenancy, right? Everyone is not exactly still depend on the node, and can still also depend on the node as well. And I would show us what that looks like in a little bit. So here we have the multi-tenancy models, which is the first one again, the namespace based, the cluster based, which is the cluster based is the one where you set up like an isolated cluster on their AWS account, GCP account, and the virtual cluster. Now, what I was trying to explain initially here is that virtual cluster typically sits on a Kubernetes cluster. So that means for virtual cluster, for example, I already have an existing or an underlying infrastructure that has been set up, right? Take, for instance, a Kubernetes cluster that has been set up, and then I am deploying a virtual cluster on an already running Kubernetes cluster. Now, This is a type of hard tenancy, and it's a type of hard tenancy because it gives you your own isolated, Kubernetes API. You get your own like Kubernetes config. So all the problem of everyone sharing a single cluster and being able to, let's say for example, being restricted to like sharing custom resource definitions, even M releases as well. All those problems are like out of the box solved with the virtual cluster. What this means is that on an already existing Kubernetes cluster with, let's say, the least configuration, I can spin up like multiple virtual clusters, and they're like their own isolated, individual Kubernetes clusters that these users can go on and completely do whatever they need to do on them. They can even set up, even their own. They can install their own ingress load balancer, and because of how native it is with the ingress, with most of the ingress controller to easily spin up a load balancer out of the box, this virtual cluster will automatically spin up, a load balancer if you're deploying to a cloud provider, for example. While the cluster-based model is, you just setting up an isolated Kubernetes cluster on your cloud provider, either using K3s or the normal K8 flavor, and the typical namespace-based logical separation. Now, moving on, here's what the namespace pattern looks like. Here is an architectural diagram using Kiosk as an example. As you can see here, Kiosk approaches this in a very different way. Because of time, I might not be able to dive deeper into the details of Kiosk, but I provided a repo I'll show shortly that provide examples on how we can try these things out. And then here you can see it has account spaces, namespaces, and the key concepts and tools here are just it uses network policy to control traffic between ports, resource quota and limits to manage resource consumptions, RBAC to manage for fine-grained access control, port security policies to define security context for ports, and storage classes for persistent volume claims. Now we have the tools here that we could use for the namespace patternant model. We could use Kiosk, which is now archived for vCluster. We could also use Kubezoo and Capsule. And like I said, I've provided a repository that run an end-to-end test of all of these tools, and even set up a Kubernetes cluster. I'll show us that shortly again. And then here's the architectural diagram of what it looks like when we're using the virtual cluster approach. So here's an example using the vCluster, and then here are some popular tools that we can also use to achieve virtualized cluster within our Kubernetes environment. So one key thing we want to take note of is using the vCluster, or let's say the virtual cluster approach, right, is still like semi-hard at the end of the day, because the Kubernetes control plane is being deployed on a host cluster itself. So it might still require, even though it provides like a more level of isolation, it might still require a little bit of more work to even further add in stuff, right? Maybe utilize stuff like gVice or Firecracker, right, to get like a virtualized kernel host, even for the host management cluster itself. So yeah, we've looked at how cool it is, what multi-tenancy can do for us, the kind of things we can use it for. Now let's talk about the challenges and limitations. Kubernetes has several shared components. I believe we all know that. So a good example for this is an ingress controller, for example. And these we usually deploy them per cluster. So if you submit a Kubernetes manifest with the same spot, and we're using the soft tenancy type of approach, and another user with the same ingress manifest that maybe probably carry the same host configurations, for example, applies, let's say, that manifest on their own end after I've done whatever I needed to do on my end, as a separate tenant who has no idea that another tenant is probably sharing this particular cluster with me. What you notice is that the new manifest that carries maybe the same host and path is going to override what is already there existing. And then the same challenges also applies to our Kubernetes API. So our Kubernetes API is by default not aware that you're using or you're doing multi-tenancy in Kubernetes. For example, say if you're like making a lot of API calls to the Kubernetes API server or thereabouts, you could get limited from time to time, right? Because it's not built by default with multi-tenancy in mind, right? And then another interesting challenge we also want to take a look at is the core DNS. So tenants can abuse the DNS and the rest of the cluster can suffer that. So we could limit this request by introducing extra plugin like the policy plugin for core DNS. So enable firewall policies, right, within the core DNS. So you might want to, let's say, especially if you're like running multi-tenancy in an untrusted environment, or you can't exactly trust the kind of applications users will be deploying within your Kubernetes clusters, or maybe, for example, you're trying to run an untrusted image. This is one of the reasons why you want to take a look at this core DNS policy as well. A tenant could also take over nodes, by just abusing live networks. And what this looks like is, say, for example, I can write a bash script that runs indefinitely, and in turn, that bash script code, because I'm running it during like a lifecycle command, for example, or a lifecycle mode, is going to, and is running like indefinitely. That could in turn like eat up my memory and RAM on my cluster and cause like the entire cluster to go down. So one thing you want to make sure you're doing is you have like you could mitigate this by using OPA, right? Like policy agents to enforce like policies even before manifest gets applied, right? So what happens is that if the open policy agents detect any manifest that goes against some of the policies that have been defined by the cluster administrator, is going to disallow such deployment or whatever you're trying to apply for going through in this case. And yeah, we also have this part which is like very, very important. So containers like offer a very weak isolation mechanism and virtual machines, right? And to solve this, right, we can use gvisor. And what this means is that, especially if you're running this multi-tenancy in an untrusted environment, where you feel like you can't trust the kind of code that these people are going to run, right? To protect breakout such as breaking out, security vulnerabilities such as breaking out of the container into the kernel host, we can introduce stuff like gvisor, firecrackers, kata containers to act like a form of virtualized, like a virtual kernel on top of our node itself. So that way, every container that is running within our Kubernetes clusters are interacting with a virtual kernel and not the node kernel itself, further protecting and isolating, even further on our end. And then here we have the add multi-tenancy part, which just talks about the trade-offs of between multi-tenancy and multi-cluster, right? So as you can see here, management overhead, maintaining multiple clusters, we already know about this. So another important thing we need to take note when using virtual cluster, for example, when we're trying to maybe do multi-tenancy in Kubernetes is the long time to recover, right? So what this means is that because we are deploying a Kubernetes cluster within an already existing Kubernetes cluster, it means whatever problem the host cluster carries, the tenant cluster also inherits them. If the master cluster is down or the master node is down, the entire tenants are all down. Now, what this also means is, so let's now take a situation whereby we're using Carpenter to save costs and we're doing provisioning based on resource and request. And Carpenter maybe, for example, is trying to like reschedule to maybe save costs, for example. So what you will notice is that from time to time, your core API, that is your Kubernetes clusters, will go down like from time to time. It might not be frequent, depending on maybe how you've configured the capital in the configuration or so, right? You can still tweak it to work for you regardless. But one big problem to actually take note of is whether you are using whatever provisioning or orchestration approach you're using to like orchestrate how you provision your node, whatever you're doing, right? You need to have it at the back of your mind that if your master node or that host all tenant cluster goes down, all the Kubernetes clusters that are within that node goes down with it. And then just like we have to wait for our pod to get rescheduled during a downtime, maybe a node goes down. Just like we have to wait our Kubernetes like reschedule the pod to the next available node, right? And pull the images, start them, and check the readiness probe before confirm them running. They has to go through all those processes, and our time to recovery could actually like increase compared to the typical approach we used to, right? And what that means is that if the node, or let's say the master cluster, goes down for 1 hour, the entire cluster hosted on that particular master cluster, that particular master cluster is also down. All of them are down, and if they are critical to your daily operations, well, I believe we all know what that means, right? So, like I said, inheriting scheduling issues, cascading on unavailability node. So node failures in multi-tenancy can render entire cluster unreachable, just like I explained. And then the last one is API limitations. So, like I said, some Kubernetes API operations may not be fully supported across all tenant clusters. So, because we're running a virtualized cluster, it's not the typical Kubernetes flavor clusters, but then he has like almost everything we need to start deploying and do whatever we need to do. But then if you want to maybe start customizing or maybe do some more stuff that I don't know, maybe things that maybe fit your use case or fit your context, right? You need to bear in mind that some of these virtual clusters might not you might not be able to do them. You might not support some of these APIs, and also it might just require extra additional work to get that done. So I've prepared some examples I would love to demo to us shortly, and so let's just quickly move to that. So like I said, I've prepared like a repository, wrote a series of bash scripts to streamline and save every one time. For anyone who is actually interested in getting their hands dirty, maybe you want to try out Capsule, you want to try out Kiox, all these tools I listed in my deck. You want to try out some of the virtual multi-cluster tools that I listed out in my deck. I've prepared examples, right, on and in these examples I wrote E2E test in Bash that all I need to do now is just like run something like this. All I need to do now is just to do like a make E2E, and what happens is that this will spin up a kind cluster, a kind Kubernetes cluster, install all of these tools and run all of them, delete them, and consider my test either failed or successful. So I have this automated in case the demo god wants to fail me today. So I came prepared for them. So yeah, so I already ran this, and here's what it looks like. Because I might not be able to wait for that because of time. And here we have this here, as you can see. So just to show that, just to show us that this works, I'll just rerun this job. And what's going to happen is, in this GitHub action flow, it's going to spin up a kind cluster. Inside the bash script, there's also a way for you to, maybe a fan of K3s, like me, you don't like kind, right? You can also do something like make install K3s in your environment. But the idea of me doing this and writing like a GitHub action flow is for you to be able to run this in maybe not even your club, maybe not even on your local PC, right? It means you can just fork this repository and just run the workflow, right, on your account, right? So you can test it without you like doing a single thing on your end. So as you can see here, it's going to set up the necessary dependency. So even if you are running it on your local, it's going to set up all these dependencies as well. And once it is done setting up the dependencies, it's going to run the E2E test. So as you can see, it's creating the cluster now. Here's the name of the clusters. To set up the node, to create this using kind. And once the cluster is up and running, it's going to, get the necessary authentication access into that cluster to do whatever it needs to do. Either install, the necessary tools. It's going to, it's basically going to look through all of them. So as you can see here, we have the E2E function, and we have our E2E bash function here that called the namespace-based function. And inside that, we just have a series of bash script function again that just run every particular tool that we have in this folder and delete them when done as well. So I believe, I think that will be all from me. I'll leave the floor for questions now. Thank you very much. And welcome to my tech talk. Thank you. Yeah, we can just wait for this to finish.
Okay, I think I'm here now. I was trying to get Favor to get me back in here. Can everyone hear me?
Yes.
Okay, the first, thanks, Alex, for your presentation. And I liked your slide. Your slide was fantastic, straight to the point, and you came ready for the demo also, so you didn't have to start going back and forth, which was good. First question somebody just asked now is, how do we get a link to the GitHub repo for your demo?
Okay, I think I'll just drop it on the chat.
Yeah, that would
everyone to access this.
Excuse me. Do we have any other question for Alex? Okay, I think what everybody just wants from Alex is repo. Okay, so also Alex, feel free to plug in your socials. How do people get to connect with you on LinkedIn, GitHub, Twitter if you're active?
Okay, so you can connect with me on Twitter at NitroCode. I'm very active on LinkedIn. I'm semi-active on Twitter, just my anime lifestyle, as I put there. Yeah, but very active on LinkedIn. Follow me there, and I think that's it. So I also dropped my Twitter handle on the chat and my LinkedIn name on the chat, so everyone can see that. Thank you.
Okay, thank you very much, Alex. We really appreciate your time. You've been very, very helpful to us and to the community, and we don't take it for granted.
Thank you.
Thank you very much.
Thank you for having me. Cheers.
Yes, sir. Favor would, Favor is currently in the other, in the other, what's it called? In the other room. We are trying to basically get everyone back in here. So It's going to take about a minute or two for us to get the other.
I mean, we could
Huh?
still take questions from the
Yeah.
audience.
I've been waiting for, if there are questions here, you could just continue answering questions until they are back here.
Okay, so I for stuff like add-ons installed on main cluster, are they scope to all clusters? So yes, if you're using the soft multi-tenancy, that is, you're just using namespace to logically separate the clusters, right? Yes, all the add-ons are like scoped to all clusters. So that means if a particular tenant has like cluster admin access to that cluster, they can access the stuff, right? Meanwhile, with the virtual cluster, that's not the case. With the virtual cluster, each tenant can install their own add-ons and it's completely isolated to them, right? But the problem with that is because you're still deploying on a master cluster at the end of the day, you're deploying on a Kubernetes cluster. So it's Kubernetes on top of Kubernetes at the end of the day. So it poses more risks because you have like long time to recoveries when your node go down because your pods needs to reschedule. Now your Kubernetes clusters are pods running on another Kubernetes environment, right? So you want to make sure that you're probably using it for stuff like pre-production environment, let's say even beta environment. You can even use it for production environment if your usage is still low for an early stage startup, and maybe just scale from there. So yeah, I hope I've been able to answer your question.
I think there are some other questions there.
Okay, so I'm trying to check the chat.
Okay.
Would you say Pipers is a software multi-tenant Kubernetes platform? Okay, so yeah, I would say PipeOps is a multi-tenant Kubernetes platform, right? But with more adding isolation provided by default. So we've had, years to we launched our first version of multi-tenancy around 2021, yes, and yes, we've learned a lot of lessons. We learned from our mistakes, right? We've had time to fine tune a lot of stuff, right? Yes, people have tried out stuff, right? That we've, find time to mitigate and also like, put measures to block them on our end. So yes, I would say PipeOps is a multi-tenant Kubernetes platform. This is one of the ways we've been able to like keep our, offering cost low and even our own infrastructure running cost low as well. What's the best way to keep different users' resources separate and secure in Kubernetes without needing multi-clusters? So yeah, right. You could take a look at Capsule, right? And one of the let me show you what this looks like quickly. One of the example I really like about Capsule is the way Capsule defines its manifest. So we can again go check what this looks like within the repository. But let me show you what the complete tenant manifest looks like. So here's what the tenant, the manifest diagram looks like when provisioning a tenant with Capsule, for example, right? There are some other ones there like kiosks, but this is no longer supported as it has been deprecated for vCluster. But we still have Kubezoo, for example. But Capsule provide a way for you to define how you want your tenants to operate and its entire life cycle. So as you can see here, I have network policy. I can define here that, these are the network policies I want any deployment that the user is deploying. So whether you are deploying a stateful set, a job, or you are creating whatever you are doing, right? These network policies will always follow whatever thing that is being created out of this tenant, for example. So if I define that I only want this ingress to be able to communicate with my ingress engineers or traffic, for example, So what this means is that for this particular tenant, the only person that can communicate with this tenant or any resource hosted on this tenant is my load balancer. And now I could see this I could also see in my egress here that I'm allowing egress to every user. So what this means is that I say to every user, to the tenant, I mean. So what this means is this user can communicate to anywhere, right? But don't forget that each individual tenant can only receive ingress traffic from the load balancer. What this means automatically is that each tenant can't communicate with themselves. Tenant A cannot communicate with tenant B, meaning the only thing that can communicate with each individual tenant is the load balancer deployed on the cluster itself, right? And you could go on to even deploy, to even like detect the resource quota you want each tenant to have, right? So you're saying that whatever deployment this tenant is running, right? Whether you're running a job, you're running a stateful set, you're running whatever you're running, basically, right? You should not use more than this resource quota. And what this means is that you're giving the users, ability to operate on their own. It's like that's like them having their own Kubernetes clusters. But then you've also avoided noisy neighbors. You've avoided unexpected scale up and unexpected, downtime due to resource consumption or maybe noisy neighbors, for example. So you can easily do that using this by setting these quotas, for example. And then you even have, abilities to, set labels that can be carried over namespaces, even, service options, even your deployment as well. So I've provided these examples, right, with different, ways you can use them, right, and different type of examples you can use, the simple ones, the complex ones. So we can just take a look at them to get more understanding and even further understand what I'm trying to explain. So the next question is, so if a K8 version deprecates an API and one of the clients uses that API, but another version is required by a different version, if you upgrade the core cluster in add multi-tenancy with that, okay. So I think I get this question. So if you're doing this in add multi-tenancy, you're not affected, right? Because don't forget, you're probably using something like virtual cluster to deploy a Kubernetes cluster, and it is own isolated cluster on its own. What that means is that whatever happens on the host cluster, like the tenant cluster does not influence the host cluster, but the host cluster can, right? So, and their versions don't need to match because why? It's its own Kubernetes API. So when you're probably setting it up using vCluster, you're probably picking a version. vCluster is probably setting a default version for you, right? So that means when you're even like deploying vCluster, you're able to, say stuff like, oh, I want Kubernetes version 1.28, Kubernetes version 1.29, Kubernetes version 1.31 in this case. So they don't affect each other that way. Thank you.
Thank you very much, Alex, for holding the fort and controlling the time while we wait for our other guys. I really appreciate it. I think the other guys are back from the breakout session they had with Mary. Yeah. Okay. For those of us that are just joining us, welcome to Localhost Conference 2024. Like I mentioned earlier, if you are just joining us, welcome. Kindly let us know where you are listening from. I think so far we've had people join from other parts of the world. I'm currently joining from Canada. Is joining from Germany. The other guy joining from Hong Kong. I've seen Ghana. I've seen Liberia. I've seen Italy. And there was. Feel free to drop your location where you are connecting from. Also, like I mentioned earlier, we have a giveaway at the end of the day. We have 100,000 naira to give out to a couple of people. Not 100K each, 50K for one person. Then maybe two other persons would take 25K or take 10K. We would figure it out as the event goes by. all you have to do is continue tweeting about the event on Twitter using the hashtag localhostconf24. So far, I have 2 people taking the lead, and these guys are already gunning for my money. That's my 50K and my 25K. If I were you, I will not allow them win. Go to Twitter, you'd see the people I'm talking about. They know themselves. I'm sure they're smiling right now. Go to Twitter, continue tweeting about the event, drop screenshots. I saw someone drop a picture of me. I can be vain like that. I liked it. So take pictures of the conference and share on social media, and yeah, you might just be the random. So I will pick 2 people that had the most tweets. Then might just pick someone from YouTube, from the YouTube comment section that has been dropping comments and has been very, very active and interactive on the YouTube comment section. Yeah, so now we should be getting ready for our next talk. And our next speaker is Piotr. I hope I pronounced that correctly. He's currently the head of engineering enablement at Loft Labs. He's an active contributor to GitHub and blogger on Medium, focusing on practical scalable solutions in cloud-native environments. Piotr is a DevOps platform engineering advocate and practitioner. Like we've been doing, let's drop our clapping emojis on our YouTube chats and welcome him to the podium. You have the floor.
Awesome. Thank you so much. Really excited to be here, guys. A great conference. I really enjoyed the talk of my predecessor. Loft Labs is a creator of vCluster, so we are deep into multi-tenancy. If you have questions about it, I'll be happy to answer also. So it was really, really, really amazing talk. So what I want to talk to you about today is how you can learn Kubernetes and cloud-native technologies using AI. So AI is everywhere, and we want to take it and make a good use out of it. So let me see if I can share my whole screen right now and grab the presentation here. So let's do this and swap to slides. Let me know if you can see my terminal and if the size of the font is all right. So let's start. As I was introduced, by the way, great name pronunciation, thank you. I work at Loft Labs as head of engineering enablement. What is engineering enablement? It's really kind of like platform, but a little bit more focused on enabling engineers in other areas. So if you work as a platform team, I've worked for 2.5 years at Upbound as a platform engineer. So I have this experience as well. In my spare time, I tweak my .files a lot. I produce videos and other content, mostly around Kubernetes, cloud native, but also NeoVim. If you happen to use NeoVim and like it, that's definitely something for you. You can find me on cloudrumble.net, and there you can find all my socials. I'm also very active on LinkedIn and would be super happy to connect with you. So let's talk about why we want to use AI to learn Kubernetes. When I say learn, I really mean more experiment and actually employ AI and play with your cluster, see what you can do with it. So especially if you're new either to Kubernetes itself, or you want to explore a vCluster maybe, or you want to do something new and you want to do this in a kind of exploratory way, chatting with AI, that's definitely something you can do. So the goal is really to utilize AI to help us learn and to ensure that AI provides more reliable answers. As a side note, I believe that the current biggest obstacle into AI going mainstream and replacing traditional workloads is actually hallucinations. It hallucinates and it's not reliable enough. So we really want to make sure that AI's answers and our learning experience is reliable to a point that we can enjoy it and take advantage of it. This being said, obviously, if you want to learn something and apply it to your production environment, definitely consult Kubernetes documentation, which is a true source of truth for everything Kubernetes related. All right, so we are going to do something out of the box, meaning we are going to have an internet search in our AI assistant. Our AI assistant will be able to connect to a kind cluster running on my computer, and you will be able to repeat it on your own. And we can tell AI to interact with our cluster. It can deploy resources, read state, and so on. So how do we want to implement it? First of all, we are going to use a program called Flowwise. I don't see a chat, but if you can like tap or tell me if you're familiar with Flowwise, if you used it before, it's a really cool project that enables you to have a low code or no code experience building AI related chains. It's based on LangChain, and it's a really nice way to kind of start working with agents or AI workflows. At the other hand, we will have a very simple Flask API in Python that will wrap kubectl commands. I did it on purpose in Python rather than going and implementing a full-blown Go API with the Kubernetes SDK because it's easier to manipulate, and for demo purposes, that works better. Now, the secret sauce of the whole idea is using function calling. We will see this in action later, but our agent will be able to use function calling, and then we are going to test it. All right, so I think with this introduction, let's swap to a demo. So let me swap right here. You should see now a Flowwise demo with a little greeting on the screen. So this is our assistant. So I'm going to demonstrate how we can interact with our cluster. And then we're going to dissect and see what are the components and how you can recreate it on your own. So first, let's say that we want to explain Kubernetes. I'm not sure if you see this, but it says, can you explain Kubernetes to me in simple terms using a shipping containers analogy? So this goes through our API, to our AI agent, and now it gives us a response. It might be a little bit too small. Let me see if I can get it slightly larger for you. That should be better. So it used actually Brave search. So it went out and searched the Kubernetes documentation, and it came up with this analogy. So it says containers are like actual shipping containers. Pods can be thought as a bundles of containers. Nodes, it's like a carrier, and so on. And a cluster is like a ship. So indeed, the analogy works to an extent. So if I would be new to Kubernetes, I would be able to understand it a little bit better, given this kind of actual shipping containers analogy. All right, great. Let's see if you can do something else. So here we are saying, could you please tell me what cluster we are running on? I'm interested in version and some basic information about it. So notice what's going to happen is that it's going to actually call out to my actual cluster. So it says it used those two functions, get version and get config. If you click, you will see that this is simple JSON output, and then it used this function. We'll see later how those are implemented, but it's important to know that it actually communicated with my cluster. So it says I am running 29.4, and this is a kind cluster, which is correct. We are actually running a kind cluster, and you can see this behind the scenes right here. This is our kind. We have a very fresh cluster, nothing crazy here. So far, we were able to read the data from the cluster. Now let's see if we can do something a little bit more interesting. So maybe let's ask our agent, I would like to deploy this simple pod. So as you can see, it's a very simple pod definition that is deploying an Nginx container. So let's do it. So I asked it to deploy a pod for me, and now it's thinking, and it should use another function that says create YAML, and it asks me, would I like to validate the actual response. So it's going to check events. I can show you the function real quick. So it used the function create YAML, and it parsed the YAML that I have given it, and the output is something I told it to do. So I'm saying yes, and it now should read Kubernetes events through another function, and then it tells me that events, the log doesn't show any errors for pod deployment, and would you like to submit another YAML? So everything is right. We successfully deployed a pod. So now, if I'm new to Kubernetes, I want to know, can I connect to it? Is there a way for me to actually do it? So let's try it also. How can I connect to the running Nginx pod and see the web app in my browser? Is there a kubectl command? So I'm prompting it a little bit. And of course, this is an agent, so it can obviously hallucinate or do something. But in this case, it says no. It's given us a command. So it gives us a port forward command. So let's see if this actually works. So this obviously should work. So I'm pasting the command here to port forward. It's port forwarding it. And I can actually grab this URL from here. As everybody is expecting, this should work. And indeed it does. Welcome to Nginx. So far, we've explored our local cluster, communicating with AI, and AI on our behalf was doing all kinds of stuff. So let's stop the port forwarding here, and we can actually try something more. So I believe I have one more. Can you explain what are deployments? So let's see how this goes. And you can see the pattern. I am interacting with AI. It goes and searches the internet when it's necessary. When it's necessary, interacts with the underlying infrastructure and kind cluster. And in this case, also it performed search. So it's always has a fresh information, and it gives me a quite decent definition of what deployments are. So, all right, great. So far, as a newcomer to a Kubernetes space, I feel confident that I can explore, I can do something to my cluster, and I'm getting responses as I would interact with a teacher. So let's see if it can actually tell us something about the current Kubernetes version. So let's do this. What is the current stable Kubernetes version, and what are the 3 most impactful features in the release? So this should again result into internet search, and our bot should tell us. Actually, it says 129, 130 is actually stable. So definitely something to keep in mind, that the responses might not always be 100% correct. But the important point is that we can explore and see what's happening. All right. So now back to you guys. Anything you want me to input in the box, anything you're interested to learn about Kubernetes or test our AI, I'd be happy to take a command from you. Unless it's not blowing up my machine, I'd be happy to type it. So I cannot see the screen. I don't want to click it because it will go into this mirror mode. So if you can tell me what to type, that would be great. Otherwise, we can continue. All right. So if we don't need anything to learn anything from our AI, we know Kubernetes very well. So let's leave it and let's swap to how this actually works under the hood. So first, I'm going to show you how our Flowise setup works here. You can see this right-hand side, that's the key component. OpenAI Assistant, you could use Olama, you could use Claude. The better the assistants become, the better this whole setup is. But this is really simple. It's called Kubernetes Assistant. And you can see it uses an open API key. It currently uses GPT-4o. It would probably be interesting to try it with the O1 preview model. And it has a pretty elaborate prompt that we will summarize in a moment, but it's essentially a prompt consisting of your helpful assistant and doing all kinds of other prompts. Here we have a tool that our assistants can use, which is Brave API, so it can search. And here we have other functions. So this is the interesting part. You can see there's a function called check events, and this is actual function. So I am calling the function name, and the description is important. Use this function to check kubectl events. And at the bottom, this is a very simple JavaScript function definition, and you can see that the URL points to a Python server running currently on my machine. And whenever this function is evoked, then this path will be resolved, and the AI will get response from this endpoint. I will show you this in a second. And similarly, other functions are working in the same manner. This is an interesting one. It's a pass-through command that enables the AI to craft any kubectl commands and then pass them through. So it's a little bit more flexible than just using predefined tools. All right, so this is Flowise, and it's open source. You can go to Flowise GitHub, and you can run it in a Docker container, and you can recreate the same exact setup as I have here. I am using it to teach Kubernetes, but you can use it for any kinds of purposes, and you can create function calling and interact with your local system for other purposes. All right, so let's see what kind of tools do we have running. So you can see here we have the Flowise itself, which just simply outputs a bunch of logs. Those are the calls that we were executing to our server. And then here you have our server that was actually responding to those calls and providing back responses. Here is the pod you remember we have created. And optionally, I would be able to run ngrok, which is a service that allows me to expose a local port to the internet. So if I want to expose this outside and enable my colleagues to call the agent, that would be possible through ngrok. All right, so that's how this works. Let's go back to slides real quick. So what we need in order to run this specific repository, we need a Python. We need a program called mprox. It's optional, but this is what you've seen here on the left-hand side. This program enables you to run multiple other programs inside of this little window. And we need a just, which is a command runner. Similarly to Makefile, it just focuses on commands. And with those prerequisites, you will be able to execute the same code as I see. So here, this is a configuration that we've seen. It starts Flowise with Docker Compose app, and then it starts the server. So what did we do to learn? So we created and validated resources. We asked for feedback about deployment. We asked for feedback about cluster information. We can do much more. We can talk about how do I scale, how do I improve security, how do I automate, and the list goes on. The good thing about it, again, is that the more models grow, they become better, they become more predictable and resilient. This solution will also improve with them. One little caveat that is important is setting temperature to quite low and top_P parameter also quite low. So the responses from the AI are more predictable and they are not as creative. Of course, you can set temperature to really high if you want it to be creative, like we talked about comparing Kubernetes to actual shipping process. This is something that you can do too. So the assistant prompt, it's very simple, but it's a bit robust. So it greets itself, it prompts to validate the correctness of your YAML. So inside of the prompt, it says, hey, your YAML might be wrong. And it uses this various function I showed you earlier, and also can pass through other commands and search API with Brave. So real quick about function calling, since this is a core component of what we are doing here, function calling is the ability to take a representation of an API, typically in OpenAPI spec, and map it to an actual function address. So we have described the function, what it's supposed to do, and then from a model perspective, we actually let the model call it, and then the function calling itself points to a URL where the actual API is defined and where we can receive information or interact with the API. So in our case, model was able to decide when it wants to call a specific function by detecting our intent. So we were asking it to provide information about version, and then it found that there is a special function that actually responds to this type of prompt and provides us the version information and so on. So it's very autonomous as to how the model calls the functions. You don't need to tell it to call them specifically. Sometimes it's good to nudge it in the right direction, but depending on the prompt, that should work by itself. So one last thing I want to show you real quick here is the server. So the server in Python is really simple, nothing crazy here. We have a very simple Flask, and for instance here we have a helper for running command, and we have this execute path. You might remember we showed it a moment ago. So I am essentially passing through any kubectl command, and then I'm running this run kubectl command, executing it, and returning a JSONify result to the user. Again, this could have been a more robust implementation. We could imagine using a Go SDK for communicating with Kubernetes, but for demo, it's actually nice to be able to change it real quick. So that's about it. I'll be happy to answer any questions or do something cool with the assistants if you guys want.
Thank you very much, Pietro, for that. It was insightful. And I don't know if you have access to the YouTube live. There are a couple of questions there, if you could, or we could just read them out for you if you would want.
Actually, you can see that on the right-hand side. All right, so I'm not sure where was the first question here. What AI tools are you using? I think from Peace. Not sure if this is the first one. Looks like it. So the AI tools I'm using is, as I mentioned, Flowise. So this is a very interesting one. Flowise is a low-code tool or no-code, low-code that is based on LangChain infrastructure, and you can do all kinds of stuff with it. So this was just one example, but definitely encourage everybody to check Flowise out. It's a super powerful tool. You can, by the way, deploy it to Kubernetes as well, and you can access it externally. You can equally well use it on your own box and run stuff with it. Additionally, there were some smaller tools like Just, it's a command runner, and mprox, which are really optional tools just to get the repository going. But the primary tool is really a kind cluster, have it locally, and then Flowise to encapsulate all the logic. All right, moving on to next question. It's not a question, maybe the role of AI in infrastructure engineering, such an exciting topic with endless possibilities. Absolutely, right? This is the future. It's a little bit, it's kind of cuts both ways. It's definitely exciting, but it's also a bit scary. There are currently tools in use that do this in much more robust way. I believe K8A's AI or something to this name that tries to kind of automate and help mostly platform engineers to do it. But definitely 100% super exciting, and this is something that we're going to see more and more. I am very wary of letting AI do everything, but as an assistant, something that can interact with my cluster and with my permission do certain changes, definitely helpful, right? All right. How many oh, sorry. This was how many pods are up and running. I didn't see those questions earlier. Apologies. But this would definitely answer this question. How many pods are up and running? It would just go ahead and execute kubectl command, get pods minus minus all namespaces, and it will give us the answer. AI-driven infrastructure engineering is redefining the possibilities of DevOps and cloud technologies. Experience the power. Yes, that's exactly similar comment like the previous one. Super interesting space. Definitely watch out for it. How can I install this AI agent on my local K8 cluster Minikube? So the agent itself does not install on the local cluster. It's just an agent that uses function calling to interact with your cluster. The component that interacts with your cluster is actually the Python script. You've seen me briefly showing the Python script. It actually wraps kubectl commands. And then the AI has functions that in turn call various parts of those Python script. So the AI decides what functions to use depending on the context. So you don't need to install the agent at all. However, the agent I used is an OpenAI GPT-4o, but you can use Ollama. So you can run all of this on your local machine. That would obviously take a little bit of your RAM and resources, but it's definitely doable. I've run it with Ollama as well. What is the quality of service? Provide a simple manifest. Yeah. That would be another question. Is Kubernetes Flowwise LLM that can learn from user? Yes. So this is very interesting. So the question is Kubernetes Flowwise an LLM that can learn from user suggestions? So something I noticed when working with this for longer periods of time is that in the session that you currently chat with the AI, it will actually learn in this session. So it will learn that you're focusing on certain things or certain things are important, and you will see that the responses are getting better. Of course, it doesn't persist anything between the sessions, so every new session is new. But inside of the session, it actually adjusts to your request, and this is just quite interesting how it's happening. How does it compare with other LLMs or assistants? So this is quite interesting. The question is, how does it compare with other LLMs or AI assistants? You can use any LLM. So you can use any large language model. This can be, in my case, it was OpenAI GPT. It can be Claude. It can be Ollama. It can be Phi, or maybe a specialized LLM that actually is trained on Kubernetes data. So this is independent from whatever API you want to call. The secret sauce is again the functions that you're exposing and the Python script that routes them to appropriate routes and then interacts with your cluster. Can I install it on my OS? So I am running this on Linux, but you should install it anywhere where Docker runs, because that's really based on Docker, and the Docker opens the Flowwise AI in the browser. So I know that Flowwise runs everywhere. So you should be able to run it on macOS, on Windows. That should work. Host space Kubernetes HK is a user-friendly platform. That I don't know this product. Also supports into, yeah, but I wouldn't be surprised that there are more like well-polished products that do something similar. The idea behind this exercise is, first of all, that you can do this yourself and you can learn in the process. You can learn AI, which is always valuable, and you're not dependent on any provider. Obviously, the other side of it is that it's not as well polished, so you're not gonna get as awesome results as maybe from a full-blown products. Can this AI assist? Yes, it can. So the question is, can it analyze observability data? Yes, it can. So you could imagine writing a function that would specifically expose an endpoint in Python for scraping Prometheus metrics, and you can throw it at AI, and you can ask it. And actually, GPT-4o has a very interesting Python abilities to analyze data sets. So it might be quite interesting, actually. It would be a very good use case to make more sense out of your observability data. And nice Tmux config. Thank you so much. I spent way too much time tweaking all my stuff. If you're interested, I have quite a few videos about doing Tmux and other config. But yeah, other than that, hope you guys enjoyed it. The repository is available with all the stuff. If you wanna check it out, I will send it here in private chat, and you might wanna share it if people are interested.
Okay, thanks, Piotr. It will be shared on the chat on the YouTube chat now. So for those that need it, they would have access to it. Thank you very much for your time. We really do appreciate your time here today.
Anytime. So it's awesome presenting. Super excited. Enjoy the rest of our conference.
Thank you very much. Thank you. Hi, hey guys, welcome back to Localhost Conference 2024. We have one more talk. Then we would have a panel session. So the panel session is designed to it's a platform where we get to ask our speakers questions. You can ask them career-related questions. You can ask them questions that have been keeping you up at night as it relates to AI in DevOps. So we shared a form now where you could ask your questions. We'll be picking at least 4 or 5 questions, at least the highest 5 questions that would be picked by all of the speakers here, and they would answer these questions not just by how they know it, but also answer it based on their levels of experiences. So it's suggested or it's recommended that you guys fill that form and ask those questions. After this next talk, the panel session will be how we'll be rounding up this awesome conference. So I will quickly introduce our last but not the least speaker for the day. His name is David. He's a senior DevOps engineer and a technical manager with a very strong background in software engineering. David leverages his diverse expertise to consult for both local and international companies with a particular focus on startups. David brings significant experience from the fintech industry, where he has honed his skills in designing and implementing robust, scalable cloud solutions. Passionate about knowledge sharing and community building, David actively volunteers and speaks at technology conferences and events like this one, contributing to the growth of the ecosystem. David will be talking about architecting for affordability, like we've always done. Let's drop our clap emojis as we welcome David to the podium. Thank you very much.
Yeah, thanks, Victor. Hi everyone. Welcome to this session on architecting for availability. So it's focused on leveraging local providers in emerging markets. So just a little bit about myself. Thanks for the good intro already. So I have around like 6+ years experience working with startups in several capacities. Most of my experience has been focused on the fintech industry with some managerial experience as well. I also love mentoring and volunteering in community activities. So these are my socials. You can reach out to me on my mail, X as well. LinkedIn, not so active there, but yeah, probably the easiest way to reach me here is a mail. Just drop me a mail. So let's continue with the rest of the session. So just a little bit of an overview of what to expect. So we'll have a little introduction, then the talk is divided in 3 sections. So the first part is essentially just a review of like general best practices when it comes to cost as relating to your cloud environment. Then we would focus a bit on local providers, what are the available ones for us here in Nigeria, how can we integrate them with our existing infrastructures, and then lastly, we do a case study review, then we have discussions. So just to get started with an introduction, right? So essentially, this talk will be focusing on us as DevOps or SRE or cloud architects, whatever name we go by. What's our role in trying to get our costs, cloud infrastructure costs under control? And if there's anything I want you to take away from the section, is essentially focusing on how you can start implementing the solutions, stuff that we discussed now. How can you go back and implement it in your own setup and start enjoying cost savings, right? So moving on, first section, just a general review of like what are the best FinOps practices, regardless of whatever cloud provider you're on. There's still like general stuff that you can do to try and save money, right? So I'll start off with a little bit of a quiz. So I want you to drop in the comment section, what do you spend most money on? At the end of the month, when you get your cloud bill, what do you think is the most, what is typically the most expensive item on the list? Is it your compute? Is it storage? Is it network? If there's something else, you can drop that as well on the comment section. So I'll just keep an eye out for that to have a sense. And storage in this case is not limited to just your cloud file storage. So basically, we're talking about your database, your logs, pretty much everything. Okay, so I'm seeing a lot of storage here. Looks like storage is leading on the poll. Okay. Yeah, because of time, I would move to the next stuff. But yeah, it seems from everything that we've seen here, most of it seems to be talking about storage being the highest cost that we have. Okay, so moving on to our next slide. So there's a typical saying that says that you cannot improve what you don't measure. So if we are talking about getting our cloud costs under control, we need to be able to measure it and have visibility into it. Now, most of the cloud providers already have tools that allows us to be able to do this, right? So it's then it's our own responsibility to take advantage of this. So integrate into them, try to build out more monitoring dashboards if you need to. And it's kind of ironic because as like SREs, we focus a lot on like, our SLOs, measuring that, the SLOs, the SLIs, your golden signals. But when it comes to money, we don't really put so much emphasis on that until, someone from finance starts knocking on the door, the CTO comes and say, why is my cloud bill this at the end of the month? So it's really important to keep an eye out on your cost as well. And also notice that it's not a one-time thing, right? It's a continuous loop. So you need to set up all these monitoring dashboards to get a sense of where your money is going to. Then you need to analyze that to essentially make informed decision, which you then lead to optimization. And this is a continuous process. So if you start and let's say the leading cost is storage today and you make some changes that make your storage costs go down, and the next month you probably have compute, and there are still things that you can do to drive down compute as well. So understanding that is a continuous loop of optimization, you're always measuring, analyzing, and optimizing. So yeah, I have some general tips that you can essentially try to leverage of what providers you're on. They're kind of like generic on the compute side, on the storage side as well. On compute, majorly is focused on ensuring that you pay for what you provision. So like don't over provision, don't provision what you don't need, right? So that includes ensuring that you're always right sizing the number of resources that you've provisioned. We already had like an excellent talk about using serverless functions earlier in the day as well. So in cases where your workload would be more suited for something like a serverless function, you should optimize for using that instead of just provisioning instances that you actually do not need. Another really good hack is spot instances. So what are spot instances? If you are not familiar with them, they are basically instances that can get restarted at any point in time, so killed at any point in time. But as opposed to like your normal instances that once you provision them, they're always running. But the good thing that they have is that they are typically cheaper, sometimes up to 65% cheaper than your normal standard VM. So when you can use spot instances, you should go for them. So a good use case, for example, is if you have like a dev Kubernetes cluster and like your nodes, for example, you can convert them to be powered by spot instances. What it means is randomly one of the nodes will go down, it would eventually come back up. But it's not life-threatening, and Kubernetes by nature, by design, can handle such disruptions anyway. So, and it's not, you might not want to do it in production and cheap because you introduce like some high level of entropy that might not be the best use case. But for other like less critical environments, you can essentially use stuff like spot instances. That's a way to cut your compute instance more than by half. At least most times you have more than 50% cost savings on them already. And then of course automation, that's your best friend. Auto scaling, essentially always again monitoring what your actual usage is compared to like the provisioned resource. So your task is always to ensure that what you've provisioned is as close to your utilization as possible. And if you can automate that, then the better. So with tools like HPAs and with Kubernetes, you can have auto scaling for your nodes to go up and down in number of size. You have VPAs as well, vertical pod auto scalers that can actually help you resize the resources that you specified for your container. So those are ways to ensure that you're always optimizing your usage. On the storage side, because of time, it's mostly just focused on understanding your data access patterns. If you know how you use your data, how you would access it, then you know where to store it, right? And you'll be able to pick the right storage classes. Do you need it in warm storage, cold storage? Do you need to put it in archival and move on, right? So essentially just try to spend time understand what kind of how your data will be accessed and understanding where to store it. And then another thing that we might be guilty of is around like just holding on to old data, right? So are there data in your DB that's no longer like useful that you can move down to like a data lake and move on, that's not going to be accessed and things like that. So optimizing around that is essentially just focusing on what your access patterns are and your retention requirement. Of course, there are regulatory requirement for around things like how long you should keep maybe like your logs and stuff. But if you don't need everything, or even if you need it but it doesn't need to be in warm storage, right, you can essentially maybe archive it and keep it somewhere where it's significantly cheaper. So some more general tips on just cost savings, right? You can set up committed use discounts or usage contracts. So if you have a sense of how long you would be using a particular product, let's say for the next 1 year, you know that you are going to need this VM is going to always be there. You have a good forecast of what your requirements is, then you can reach out and set up committed use discounts. So that would again give you discounts of up to sometimes 20-30% on your cost, driving it down. You can also set up like contracts, reach out to your account manager, AWS, GCP, and try to get that. That's weird. Can you drop in the message if you can't see me now? I'm hearing that my camera seems frozen. Is that the case? Can you guys see me? Right, moving on because of time. So there are still like some general acts that you can do, right? Essentially around your cost optimization as well. Have a sense of, oh, it is, that's weird. Okay, so let me just restart that and see if it picks up now. Right. So again, on like general cost savings, you can make use of things like infra costs to sort of estimate the cost on your PR. So it's an open source tool that based on changes in say your Terraform file, it can give you a sense of how much it's going to cost you. So if somebody releases a PR and then there's already a sense of how much that is going to add to your cost bill, then you should have a sense of that. While saying that, you can also review your designs with your cloud providers. So what I mean by that is reaching out to your cloud providers. They are always more than willing to help. From my experience, you have startup ecosystem managers for AWS, for GCP. I've worked with both of those major providers, and they're always willing to help. You can have discussions with them as regards what you're trying to do. You can review your decisions with them, and they will let you know how best to go about it. For example, if there is a better way to take advantage of some of their tools, or there's a cheaper solution out there. So it's always good to essentially try and run your designs by them. And then lastly, they all have like recommended guidelines on cost savings. So at the end of the slide, I've added the resources section that talks about that. So regardless of whatever provider you are using, just go to their docs. You see best tips on how to ensure that you are not overpaying. So moving on to the next section, we're talking about the rising cost of infrastructure costs. So what is the problem and what's responsible for that, right? This is primarily driven by the exchange rates, right? We know that the primary reason why our infrastructure costs have been rising recently, I've seen a lot of people screaming about it on Twitter, on LinkedIn, as well as being our exchange rate, especially after the parallel market and the official rates were unified. That led to like a high jump. Now it's still continuing to rise. So basically, I don't even know what USD is at today, but like that's what has been a major contributing factor to the rising cloud costs. Another problem, right, to think about is that our cloud bill is calculated in USD and invoiced in USD. So I'll explain what I mean by that. So in terms of like the calculation, that's talking about the price per unit, right? So if it's something like compute, for example, you are charged by the VPC minutes that you're running. So your virtual CPU rather, vCPU minutes that you're running. So you are built based on that, and that unit pricing is typically in USD, right? On the flip side as well, when you get your bill at the end of the month, you need to actually pay for it in USD. So that gives two problems. First is that you need to actually source for USD to make the payment. And then the second aspect is that you have no idea what your true cost for your clouds is. So imagine you have 2 months, you spent exactly the same thing in USD, but because the exchange rate keeps fluctuating, then you need to pay something different. So you can't really budget and have a real sense of how much the cloud cost is. So there's some current workarounds that people are developing. So typically around payment partners. So some cloud providers, I know GCP, AWS also has like cloud partners in the country that are willing to accept your payment. So you will pay them in Naira and then pay your USB bills for you. So that solves the problem of needing to source for Forex, but at the same time, it still doesn't solve the problem that your cost can keep fluctuating because you still keep paying, you're paying in Naira, but the billing is still coming in USD, right? Moving on, so to get a permanent solution to this, basically two things need to happen. Both the billing leg and the payment leg need to happen in your local currency. In the case of Nigeria, we're talking about Naira. So that means the cost per vCPU, for example, should be charged in Naira, and you should be able to pay in Naira as well, just not one side of it. Unfortunately, I don't think we're ever going to get to a point where Google will start charging per vCPU minutes in Naira, right? So even if you find a way to pay in Naira for the payment leg, your billing is still going to come in USD, which means it doesn't solve your problem. So only local providers can really solve this problem of both the billing and the payment legs. So moving on now, let's talk about our local providers. What are the opportunities that they offer us? So these are some of the popular local providers. This is not an exhaustive list by any means, but the top popular ones, we have MDXI by Main One. We have Novus Cloud, there's MTN, there's Layer 3 Cloud, there's Google Host, there's Rack Center. We have MTN as well. So then you would have asked the question, if you already have like some of these local providers, then why are people not using it? Why are they still complaining about the high cost of cloud, right? So that leads us to our next slide that talks about the obstacles that are preventing the widespread adoption, right? So one of the top problems is accessibility, in the sense that most of the large cloud providers, talking about Main One, that's MDXI, MTN, they only want to work with like large corporate clients, right? So while working with like one of the big fintechs in Nigeria, we reached out to MTN to even try to get like rent out some VMs in like their data center and stuff, and it was almost impossible to get any response back from them. The Main One was so tedious, involved a lot of contracts, legal back and forth. Compare that to something like GCP, where you basically just sign in your Google account, put your card details, and you move on. So they are not readily as accessible to everyone as our normal, typical global public providers, which is one of the issues why people are not really adopting our local providers at the moment. The second problem is, you have limited platform as a service offering. So even when you get access to these local providers, most of them, what they want to offer you is bare metal, right? They'll give you a VM. They give you, okay, this is the box. At best, maybe it comes with Linux or something installed on it. We've given you the VM. We'll give you internet access, like go and sort the rest out. Most of the time, you might not necessarily want to, go down to the level of managing that. You typically want something level higher if you are familiar with solutions like Heroku or Google's Cloud Run and solutions like that. Or even like functions that we've spoken about it earlier, right? So you wouldn't want to go down to the level of working with bare metal. There's also the problem of the pricing model, which is on the popular providers. You have pay as you go. Unfortunately, with the local providers, you either need to pay quarterly, monthly contracts, right? Which you need to pay maybe at the start of the month, at the start of the quarter. They don't offer you as much flexibility when it comes to payment. There's also the issue of reliability concerns that people have as regards them. This again, I've had my own fair share of it as well. So for some personal use, I won't name the local provider, but I had a local provider that have like a box with them, and I woke up one day and my VM had been deleted. I messaged them and I'm like, hey, what's going on? And they're like, oh, there was some script that ran, it was a mistake, blah blah blah, and there was no way to even recover it. I was like, do you have any way to like? So when do I get my VM back and whatever? They're like, so like, I go and provision another one and like do the installation again and everything. I'm like, oh wow. So just imagine like you're running a company, you just wake up one day and a bunch of the VM has disappeared. So that was a while back. I believe that they've gotten better now, but you can imagine that the reliability concerns of people are genuine. But at the same time, you also need to think about, I have this hot take that I have a couple of my friends always discuss that the Nigerian consumers don't focus as much on reliability as we think. And like, so I'll give you an example, right? So most people have like these commercial banks and every other, like 2 weeks ago, I remember my mom said complaining about Zenith Bank being down for like weeks. She's unable to do transaction and whatnot. Now I asked her to move to maybe a newer bank or all of this. She's like, I'm fine, I know Zenith, I'm still using Zenith and whatnot, right? So maybe really that 99.99999 reliability that you're looking for it's not if you can save money and maybe get like 95, 96, it might not be the best. It might not be the worst scenario, right? So, or maybe 99.9 itself, you don't get all the extra nines, right? The other issue is around managed services. So most of us, we prefer for different reasons, right? You might not have the skills, the team might not have the skill set to manage, say, DB, for example. You might not have like the right resources, or you just prefer to focus on like your core offerings and the rest. So you want to use to like manage DB offerings. Or for example, I wake up and I tell our data team that I want you guys to move off GCP and you now have BigQuery again. They always strangle me, right? Because they loved it. So that's like one of the things they use the most, right? So if I say we are leaving GCP and we are carrying everything to maybe main one, am I going to give them BigQuery on main one? Most likely not, right? So managed services is another reason why people have like one leg in one place and one leg outside as well. So, but with all of these problems, then you now wonder, is this still worth trying to compare this? That's weird. It's not showing the full slide. Part of it is truncated. Okay. A part of the site is truncated actually. I'm not sure why. So but basically it doesn't show the full comparison, but we can use the one at the top, right? Just to get a sense of what's going on. So you have a VM, you see the costs across different environments. So we're talking about this particular sort of VM on AWS, it will cost you around $100. On GCP, it will cost you around $144. On Nobles Cloud, one of our local providers, it will cost you 56,000 naira, which is just around $34. Right? So you can already see the cost saving. That's almost $60 that you are saving on one VM. So if you have 10 of that, you are saving $600, right? So you have 100 of that. Now you're saving $6,000. Same thing with MDXI, right? So to just give you a sense of it. So this calculation was done at this dollar rate. So because of this cost savings, it's impossible to then decide that we want to ignore our local providers, right? So you need to still take them into account, right? So there are ways that we can overcome all of these obstacles. So the solution that I propose is sort of an hybrid approach, which is, can you get the best of both worlds, where you combine the guarantee and robustness of your top public clouds with the cheap compute and storage that you get from the local vendors. So in terms of like design, what would that look like? So if you're already familiar with multi-cloud setup, so we had a talk earlier that I was talking about like presentation on multi-cloud, I think it was Divine. It's pretty much similar set. So on this side, you have like a local cloud environment. On the other side, you have like a global cloud environment, maybe GCP, Azure, or whatever. You have some high-speed interconnectivity between them. That can be like a VPN setup between both of them. And then you just have a load balancer sitting front, splitting traffic. So I put configurable traffic splitting here, such that when you start out, for example, you might be routing just 10% of your traffic to the local cloud provider, while 90% of it still goes to your global provider. So that gives you a way to start taking advantage of this. And as you become more comfortable and you test out the waters and you are more comfortable with it, then you essentially start, increasing the volume of your traffic that is going to your local provider. So at an high level, this is what like sort of that architecture will look like. So you have an high availability load balancer sitting in front. You are splitting the traffic to both environments, and they are interconnected with some high-speed interconnectivity between them. But if you do an hybrid system, what are the possible implications that you might have? Of course, you need to consider things like latency, your bandwidth, your reliability. You already mentioned that. So do you have like some SLAs that you need to meet, and going to a local provider, would that cost you? Compliance as well, in terms of you're adding a new probably location, a new environment. Are you allowed to move to those locations? And also, what is the compliance requirements? Monitoring and management. Now you have more things to monitor, more things to manage, and overall, because of the architecture, you are just making the systems more complex. So it's not entirely sweet, but it's kind of like a middle ground. There are things to consider based on your scenario and what you should implement. So I did a little bit of experiment. I have the results here to discuss. So in terms of performance, we mentioned both latency and bandwidth. In latency, you kind of have like a very easy winner, in the sense that if your customers are in Nigeria and you are hosting Nigeria, then you would have way less latency, because you are basically just trying to reach your servers there in maybe Lagos, Nigeria, for example, right? So, but latency is not the only thing to consider, right? Depending on your type of application, if your application is data intensive and you're moving a lot of data around, then you need to focus on the bandwidth as well. So what you have here, I did an experiment. I had like 7 different people try to reach 2 servers. One is based in Lagos, one, and the other is in GCP. So we use a tool called IPF3 for the test, just to sort of get a sense of what the transfer speed is. You would see, and then the different users are using different networks. So you have like mobile users, MTN, Airtel, and the likes, and you have people using like fiber, like Fiber One, IPNX, and the rest. So there is that wide distribution. What you would see, funny, is for most people, it still seems that their download speed, essentially the throughput speed that they experience while trying to get stuff from GCP, is actually higher than that of main one. So if your use case, for example, is something that is data intensive, then you have no business. Well, if you move to something like main one and you move a lot of your data there, right, then your users might start experiencing a little bit of lag, right? Not in terms of maybe loading, for example. Let's say you post videos or like video sharing platform and things like that, right? And because of that, such limitations, you'd have stuff like that. So the latency, they will pitch to you like moving closer to Nigeria, that reduces latency. But latency is not the full picture. You need to consider your network bandwidth and throughput as well that you would experience. On the upload speed as well, it's kind of like a tie for most speeds. Although it seems like one kind of edges out slightly in some cases, but for most places we see that the difference is not that much. So basically it means like for upload, you're better off trying to upload, right? So again, this is just at the network level. So what really depends on how the performance of the application would be affected really depends on your application and how it works, right? So you're better off doing like a full-blown test where you deploy your application on a local provider and a global provider, and you compare, you do all your measurements for your throughput, for your latency, and things like that. Then in terms of the last part of it, before I conclude, I'm talking about like this just shows an overview of an actual system that has been implemented based on this architecture that I explained. So sort of like an hybrid approach. Excuse me. So the 2 providers they were used in that case was Google Cloud and main one. So down here you have on the lower part of it, you have your local provider, and on the upper part of it, you have your Google Cloud, which is the global provider that was used. Now, both environments are connected together using high-speed interconnecting the VT. So a VPN, in this case, WireGuard was deployed essentially to connect both environments. And then for your configurable traffic split, that was placed. Ideally, you want to put your load balancer as close to your users as possible. So you might have considered putting it in the local environment, right? But unfortunately, on the local environment, because of the reliability issues and the rest, you really want to avoid a single point of failure there. So it probably makes more sense to put it somewhere more reliable. So you might have considered your global provider, maybe GCP. But in the case of GCP, then it becomes redundant if the load balancer that sends people back to Nigeria is in GCP, then you lose the advantages of things like latency, right? Because first, then for any request to even be answered, they then have to first go all the way to something like GCP in maybe whatever region you are using here, or maybe South Africa here in the and then coming back, right? So, but I don't know if you guys are aware, but Cloudflare has a presence here in Nigeria, and they also have a high availability load balancer. So that's something you can take advantage of that was used in the actual implementation that I was discussing. So, and it's a global company, it's quite reliable. So essentially, the high availability load balancer that was deployed was Cloudflare, and because they have a presence in Nigeria, so you're essentially entering their network here in Lagos, Nigeria, and it can easily route you back to either main one or Nobus Cloud or the rest that you have. So you can check the design out more later in the slides. I know that will be available after. And then there are some local cloud providers to keep an eye on, especially around managed solutions. So we have Ospace NG. So it's a new arrival. They offer managed Kubernetes offering and managed container services. So they kind of resolve the idea of having to manage everything bare metal for you. So you guys should check them out. I've added the link here, spaceng.com. There's Nobus Cloud as well. So one of the traditional providers, they explained that they now have container service. So I put asterisks there because I saw the mail, but I was actually unable to use the container service when I tried it out. I could not see it in my environment, my account, so maybe I need to reach out to them. Maybe they've not rolled it out to everybody at that point. And then there's Nebula, but I think that is currently in beta and waitlist. So one of the things that is interesting about those guys is they say they would have a managed DB service. So if you can have a managed DB service, then for people that the reason why they don't want to go the local provider route is because of managed services like DBs and the rest, and that offers like a good solution for them. So these are like some of the resources that I've used earlier in coming up with the slides, the pricing calculators, resources on corpus customization as I mentioned. And that's pretty much it. So time for like questions. If you have any questions, feedback, please share them and let me know. That's it from my end.
Thank you very much, David. Thank you very much, David. There are some questions here. I don't know if you were able to answer them in the course of your. I know you're able to touch on a few in the course of your presentation, but are there others here that you think you need to talk on, or you've covered everything? Hello, David. Can you hear me?
Yeah, I'm with you. So I'm just wondering if there's any of the questions you want to call out specifically.
For GCP users, okay, those are more like comments. Okay, yeah, I think they are not really questions.
No real questions. Okay. I'm sure that's good then. Thank you everyone for the session, and I hope we start using our local providers.
Okay, now we will go back to the last leg of our conference. Thank you very much, guys, for still being here. We've been here for about 4 hours now, and we started with about 80 something. The highest we got to 110 or so. We have about 67 people still here. Thanks very much for taking time from your rest, from your weekend to join the live stream. Don't forget to like, comment, and share the live stream. I mean, we have 68 people currently streaming. I want us to also all like the video and share. What this does for us is it improves the algorithms for the video and helps the video get recommended to other people that don't even know what is going on here. So our last and final leg for this conference would be a panel discussion where we have all of our speakers come on board to come on the platform and answer your questions. It can be career related questions, it can be DevOps related questions, any question that you think is keeping you up at night as regards AI and DevOps. Now is the time to drop those questions and have people with wealth of experience share their knowledge with you and customize the answer to what you want rather than giving you generic responses. Also, we have winners already for our 50K to 50K, then 30K and 20. That's 50,000 naira, 30,000 naira, and 20,000 naira, both on Twitter and also on the YouTube chat. But I mean, you can still continue tweeting, and that we've picked them as winners now does not mean I cannot go back and check and see that this person has gone up the dashboard. So don't stop tweeting, don't stop using the hashtag, don't stop sharing screenshots of the conference. But right now, I would get Ido to come up and lead the panel session alongside every other speaker that have spoken in the conference so far. So like I said, what did I do? Fabian, what did I do? Yeah, that. Let's welcome Ido.
Hi, everyone. So first of all, I think we should give all the speakers a round of applause. They've actually given us quality talks for the past few hours, and I think it's something that is commendable. Now for the panel session, I'm not sure how to go. Are we going to add all the speakers back? Okay. Okay, we have some questions already, and please feel free to ask questions as the conversation is going. So I'll first of all start with the questions that was added to the form, and after then I'll gradually start asking more questions that I believe would be practical or would be useful to members of that, everybody that have joined the meeting so far. Okay, so I'll just jump straight in. I don't think we need any form of introduction since everybody here have already been introduced and have given their quality talks. So the first question is, as an entry level position, how can you network or get jobs slash internships that can make you practice some of the skills you have learned? So basically, this is an entry level person or a junior DevOps engineer that is asking what are the how can the person network, what can the person do to get a job that would help them improve their skills or actually put into use what they have learned so far. I would actually direct this question to Divine, and please feel free to unmute yourself if you have something to add after Divine goes.
Yeah, so just to be sure I got the question right. So like how to like get opportunities and get better, right?
Yes, yes.
Yeah, so I think we can all agree the easiest way, which is like easy in quote, right? And like the best way will be open source, right? So getting involved in open source projects, open source communities. I think that's what helped me a lot, right? Being involved in open source projects and communities. So there are so many like Google Summer of Code, there are Linux Foundation sponsorships and stuff, right? Some organizations here in Africa, like I know Demos Cloud, do some like internship and stuff, right? So looking at those opportunities, right? So for you to learn from more experienced people and contribute to things that people are using in the real world, right? And aside from that, then on your own you can build projects, right? So building project, a lot of people ask, so what will I build? What can I build? How will you know what you build? So you just ask questions, right? So if anyone that has followed me or following me on Twitter will know that I always ask questions in public. So you can tag someone, even someone that you've never met before, right? I've made connections with, like, I had a conversation with the CEO of GitLab through Twitter, right, asking a specific question, and he opened his DMs and he replied me, right? So everyone is willing to help. So ask as much as questions as you want. That's how would be my general advice. So open source, asking questions on what to do. So when you're talking with someone, you tell them where you've been, what you're currently doing, and what you want to do, right? So they can like guide you through that journey. So yeah, I hope this helps.
Yeah, I want to add to what Divine has said. So you can also join Chaos Africa. That's Roots. I don't know if you know Roots. She's leading some efforts in open source there. We actually have projects that need people to contribute, mostly DevOps. But I think right now I'm the only one, and I would appreciate if people can join in, and I assign tasks to people because I mean, kind of busy and all that. So the project can move at a faster pace. Another thing is when you join channels, you join communities, always introduce yourself. Oh, I am a DevOps engineer, anything I can do. I mean, that was exactly how I even got to know, like, oh, they actually have projects that need people to contribute to. So you also like keep an eye out for projects, you talk to people, and you need to have your evidence. So you coming on an open source project, I need to know what have you done before. So I know, okay, you've done XYZ before. Definitely you have the skills to apply to ABC. So you need to also build your portfolio, speak up for yourself, and put yourself out there. Thank you.
Thank you very much, Mary. So the next question will be directed to Femi. And the question says, how do you balance the need for speed with ensuring security and compliance in a fast-paced DevOps environment? Femi, you can unmute yourself. I think
Okay.
camera is
How
on.
do you balance the need for speed and security?
While ensuring security and compliance in a fast-paced DevOps environment. I'm directing this question to you because it's mentioned something about serverless and serverless and everything revolving in a fast-paced DevOps environment. Is it my network? Oh, okay. Femi, you can go now if you can hear me.
Can you hear me?
Yes, we can hear you now.
All right, all right. I was reading back the question. Okay, I got the question. So how do you balance speed and security in a fast-paced DevOps environment? That's it, yeah?
Yeah.
Okay, so basically, when it comes to speed, there are major factors, that should come into play, right? When in terms of speed of your application, there are several things that can be optimized from, the resources that you allocate to your applications, and also on the database side, and then also how well you properly manage, these resources on your code base as well. That's on the implementation side, So in a fast-paced organization, there are several things that you can easily like forgo, when it comes to security. But it's really important for you as a DevOps guy to ensure that you have, the proper underlying infrastructure, for security. So even if an engineer by mistake, doesn't properly secure his code, based on the fact, that you are trying to like push things quickly, you're trying to push things quickly and all these end-to-end security like measures are not in place, it's important that at least on the network level, these things are like are properly managed, because at the end of the day, I see network as basically your kingdom, right? You want to make sure that even people in your kingdom, even if they don't secure their own environment, you as the gatekeeper of that kingdom, you have to ensure that you have structures in place to avoid loopholes into your network, right? And then that's on the network level, right? Now, down to the application level, you also have to ensure that, for example, if you are building like a microservice, if you have like a microservice architecture where your microservices get to talk to each other and basically like to like exchange data, interact with external services as well. You have to ensure that there is proper service to service security. It could be API keys, that only the two services have access to, and like properly managing those keys. Maybe if it's on the cloud, you have services on AWS like secret manager, where you can properly like manage secrets, have like a rotation, have these keys like rotate at periodic times, so that those keys are like properly managed. And then even if they are compromised, they get rotated, at a periodic time. So these are like high level, measures that you can put in place, and like I said, it's a continuous process, right? It has to be like a culture, right? And most times people know how to implement, but then they don't know how to properly secure the application, right? It's something that people like see as a secondary part of engineering, even DevOps or even software engineering as a whole. But actually, it's not secondary. It's really primary. It's key. Aside from your application working, right? Security should be like a primary part, of whatever it is you're building. So these measures like have to be in place, like I said, on the network level and also on the application level as well.
Okay, thank you very much, Femi. Does anyone have anything to add to what Femi has said?
Yeah, I would just like to add as
Okay.
well that it should be security by design. So as if you're handling like security, you want to get involved with the old design as early as possible. So if it's a new feature, during the stage of planning stage, don't wait until you get ready to go into production and they hand it over to DevOps. So try to get involved as early as possible in making the concrete decisions as regards how things will be deployed, to ensure that it also helps with the speed of iteration, because you don't want a case scenario where it's already about to go in production, then you discover some security issues, and then you then have to send them back and say you can't maintain this in production. So try to get engaged with the team as early as possible, if possible, from when they start designing and considering the future.
Thank you very much, David. Coincidentally, the next question is directed towards you. And the question says, what are some successful strategies you have seen for embedding a DevOps culture in an organization resistant to change? I mean, let me try to buttress the question. In most cases, even software engineers or business people, most often than not, they are resistant to something changing. They are resistant to introducing a new tool or things like that. So how do you navigate that based on your experience? How do you advise that is navigated to make sure everybody is on board to a new change?
Sure. Yeah, that's fair. And like you said, yeah, people are typically resistant to change. Even us as humans, basically, even DevOps people, we're also resistant to changing stuff, right? But change is constant, it's part of life. So I think on that side, right, the first thing is to try and get people's buy-in before you even get to the point where you are trying to, you just don't come out and say, from now on, this is how everything is going to work. This is what is expected from developers, right? So you try to get buy-in, right? So depending on how the organization is structured, you have like the key stakeholders that you need to talk to. So if you are intending of changing the structure or how developers and DevOps work, ensuring that they are more involved. So for example, in the last answer I gave, I was talking about being more involved in the design, right? So obviously, as a DevOps person, you can propose that to say maybe your technical leads, they might feel like, oh, are you saying that they are not doing their job well enough? Are they not, they are responsible for designing the system, right? Are you saying they are not putting security in place and things like that? But depending on how you approach the matter, if you bring it up, as a discussion with maybe one or two of the tech leads and say, hey, we have this kind of issue that we've seen. We think, if we approach this in terms of getting people early involved, in being able to spot all of these issues. You can prevent issues when you eventually get to production and improve the speed by which you're able to get into production. So being able to navigate getting buy-ins from people, discuss with them. Then another easy way is to also show people. People will typically follow when they see that something is working, right? So look for a way to essentially do a miniature version of it that works, right? So for example, if you have internal tech talks, you can do a tech talk, first discuss your proposals, the pros and cons, have an open discussion with the rest of the team as regards, what they think about it, right? What's their fear towards going through this, what they think is going to be the good side of it. So once you have those sort of like open discussion, by the time the change eventually comes, it doesn't really become so strange to people. And then the last tip is to find early adopters. So regardless of how people might be stubborn, there's always going to be that guy or that team that is really excited about trying new stuff out, right? So try to find those early adopters. Those are the people that will join your wait list. Those are the people that are excited to know about DevOps culture. So try to work with those guys, and then they'll be the one that will start evangelizing it to the rest of the team. So I would say that's how to go about it. Try and first get buy-ins from your key stakeholders, and then try to show people at a small scale, and then focus on your early adopters. So those will promote it within the organization. Thank you.
Thank you very much, David. Does anyone have anything to add before I go to the next questions? Okay. The next question is for Alex, and the question is about incident recovery and reliability of applications. And the question is talking about how do you or your team improve incident response and minimize recovery track time during critical failures?
Okay, thank you. So one of the key things we do is we take care of this at the foundation of our infrastructure setup. So as at the time when we are, writing our ISA configuration, we make sure that we have at least about 3 availability zones, and we make use of Kubernetes. So when deploying or making our deployment, we can set like topology spread to like set the requirements for Kubernetes to spread our pods across these zones and all of that. So if for any reasons, let's say any of our node goes down or something, because they are always like spread across like 3 in our availability zones, we can always fail over to like different zones from time to time. And then we have so another strategy we use, because we also like do pool providing. We provide like pool, and that's where like our users like create servers from. And what we do is that we also like to like separate our workload, like separate consents. So take for example, so all the tools that we know that are required for our applications to run, like SAT Manager, we need Kubernetes Stack and the rest, right? We put them within a particular node group and paint them, and then we could set them to like run on their own, let's say, node group. And maybe even if we're using Carpenter, for example, they could use Carpenter to like dynamically provision whatever they need to. So that way we have the workload that actually just like power our, just empower our clusters to work, running on its own, separate, isolated node pool. And we have our own workload itself running on its own node pool as well. And they can all like spread across like different zones. So this way, we're able to separate concerns, and by doing that, when we are having, let's say, noisy neighbors from maybe Prometheus Stack or Ingress Controller, or maybe any of our services, external services that we utilize, causing a spike, for example, it does not like directly affect our main application itself or in any way, because they are all like completely isolated from the main application itself. I hope I've been able to answer the question.
Thank you very much, Alex. I was muted. I think you've been able to actually like expand on what the question was, and I think it was a good answer. Thank you. The next question is from Mary. And the question is, I'm directing this question to you because you spoke about observability. The question is talking about how do you handle metrics overload? And basically, if I can buttress on the question, it's basically directed towards what are the key metrics that we should prioritize? What are the key metrics we should focus on? When do I know that I'm over monitoring some metrics? How do I know I'm under monitoring and everything around that? And how do I manage? How do I make sure I'm just monitoring the right number of metrics for my DevOps processes?
All right. So the first thing is to identify your business needs. Like in during the session, I said if you are a food business, you have no business. Sorry, you have no business keeping track of probably the outfits people wear to walk into your shop to buy food. You have more business with what food sells at what period of time, so you can track like okay, in the mornings, maybe rice sells more in the morning. So that means you make more rice in the morning to make more profit. Whereas if you're a fashion business, you care more about what are people wearing. If people wear maybe trousers more to your shop, you know, okay, stock more trousers, make more profits. Then if you're talking about the main things to monitor as regards the system, I would say your CPU, your memory, your disk usage, and probably your network latency. Those four should be key metrics. Every other thing is an add-on. And when you talk about over monitoring, like you monitor too much, I would say see how start small. But as time goes on, maybe there was a downtime, and because of that downtime was something you were not monitoring before. You add that to a list of things you're monitoring, or maybe you notice like, okay, this thing I'm monitoring, I haven't maybe seen the use of it. You can take it down. So everything is just it's up to you as the engineer to observe, to learn patterns and adapt so that you're not overwhelmed by your monitoring process. And answers the question.
Thank you very much, Mary. Does anyone have anything to add to what Mary has said? I think she made very valid points when it comes to it's you have to just weigh and then always continuously, like what Femi said, you have to continuously go back. Does this work? Does this not work? Remove, add, and things like that. Thank you very much, Mary. Then we have one more question before I go to general questions that will be thrown around to anyone that can answer. And this question is for Piotr. The question is talking about, and this question is directed to you because you spoke about Flowise, which is an AI tool. And say, for instance, I want to introduce this to the company I work for. How do you advise, or what are the processes that you would recommend in selecting and integrating a new tool to the DevOps switching of my company? So say, for instance, I'm a regular DevOps engineer or I'm a senior DevOps engineer. What should I look out for in tools? Okay, I have several options of tools. What should I look out for in selecting a tool and integrating it into what we currently have that works for us? How would you advise?
Yeah, absolutely. So there's definitely a generic vetting process that you have to follow, which is just to check the health of the repository, how many commits, who owns the repository. So there's various ways of looking at it. You need to make sure that the license is in accordance with your company policy and so on. So once this is done and you're happy with support and other things, it's always good to look for commercial vendor that might offer support for the product. However, you mentioned that you already have a DevOps engineer, you're comfortable running it on your own. You need to decide whether this is something you can support. So kind of check, inside knowledge. Are people that are going to deal with it equipped appropriately with installing it and configuring it, and then just give it a try, see if you can install it. And one very important thing is to see how you integrate this inside of your workflow. So you would need to discuss with your shareholders what are the needs, how do they want to use the tool, and what are going to be your responsibilities. It's very often a question about, do we want to run something on our own, which will contribute to, existing costs, right? We will amortize it in existing costs, or do we want to outsource it to a degree, as I mentioned earlier, whether there's a SaaS offering that we want to consume, or maybe outsource it completely. But I feel that once this is done and you're comfortable with the licensing, you can definitely just start exploring, whether your technical capabilities are sufficient to support it, and what is the scope and what are use cases. With Flow specifically, it's a very strong technology, and there's a very also strong community behind it. So I would say that's a little bit of an easier entry than with some less known tools. You're muted,
Yeah, thank you very much. Does anyone have anything to add to what he has said? Okay, so I'm done with the specific questions for each of the speakers. I have two more questions that are general questions, so please feel free to unmute yourself and answer the questions if you have answers, and feel free to add to what any speaker has said. And the first question is, what are some emerging trends in DevOps that you're excited about, and how do you think they will shape the future of software development? So anybody can answer, anybody can chip in, and it's just a general question for the speakers.
So maybe I'll start real quick. So for me, Kubernetes is not only a workload orchestrator or containers workload orchestrator, but it's becoming more mainstream in how it can orchestrate anything. So Kubernetes resource model and its API model, it's more and more used to do other cool things. A good example is Crossplane. If you're not familiar, it's a project that essentially uses providers similar like Terraform, but uses Kubernetes, CRDs, and other components to run and create and manage your infrastructure. And more examples of this come up, projects like KubeVirt and others. So it's quite interesting to see how Kubernetes becomes more of a universal control plane rather than just containerized workload orchestrator. So definitely something to keep an eye on, especially if you're in a platform engineering space.
Speaking about Kubernetes, would you, based on the cost benefit ratio for Kubernetes, would you recommend Kubernetes for a startup?
Kubernetes for a startup? Absolutely. If you are a startup that works in a cloud native space and you want to manage something, let's say you have a multi-tenancy solution like Alex was explaining, definitely you need a managed Kubernetes. So I know very few startups, I know some, but very few that actually run something on bare metal or on-prem, simply because the effort is really, really high. You can use things like Rancher to make it a little bit easier. But yes, if you want to run something that essentially runs your infrastructure that you expose multi-tenancy on, then Kubernetes is definitely an interesting choice. Of course, that means that you need to know it and understand. If you have, very good engineers that specialize in Docker Swarm or, other services, and obviously use this. But if you can use Kubernetes, that's a good way to do it.
Cool, interesting.
Any other person? Yeah. So just to answer your first question, I think one thing I'm very excited about is self-hosting. I do believe personally that the future of cloud hosting is self-hosting, and I see Kubernetes being at the forefront of that. Right. Currently, right now, there are tools that allows us to, so you could use Kamaji, for example, to provision a cluster and join nodes from anywhere, like GCP. So I feel like we'll get to a stage where anyone could just convert their PC and be able to host the website from there, and then we could all have like a portable device at our comfort, and that could be like where we store our drives, and even maybe where we host our websites, for example, or even our applications. So yeah, I do believe the future of cloud hosting is self-hosting.
I think I am with you on that, because with every announcement Apple makes, they are increasing the resource available to. They're increasing the resource we have for our machines. I mean, I'm seeing 1 terabyte. I'm seeing 64 gig RAM and things like that, and more and more. So I can as well just host my React app on my laptop instead of paying a few bucks to AWS. Yeah. So
I mean, it's just a tunnel proxy. That's
yeah.
all you need.
Yeah. Okay. Nice. Any other person excited about any new trends in DevOps? All right. Cool.
I'm seeing
So I will.
work
Okay.
here
David.
in SRE. So can you hear me?
Yeah, your voice is breaking.
It seems this.
David, are you trying to say something? Okay, I think we lost David. So I will just ask.
No, it's fine though.
Okay, I'll ask the next question, which is the last question actually. So please feel free to chip in. So the last question is: what advice do you have for companies or DevOps engineers or DevOps practitioners who are just beginning their DevOps journey? So it's a two-phase question. First, from the company perspective, and second, from the engineer's perspective. So either ways, what advice do you have for these parties that are just beginning their DevOps journey? Feel free to unmute. I can start first, in case nobody wants to unmute. I think for companies, I would say the first advice would be give junior DevOps engineers a chance. Junior DevOps engineers grow to become mid-level and become senior. And I'm saying this emphatically because someone also gave me a chance as a junior DevOps engineer while I was transitioning from software engineering a couple of years back. So I think, yeah, that would be my first advice for companies. If you can, please give junior DevOps engineers a chance, and then, yeah, you most likely will not regret it. I can't vouch for anybody.
Okay.
So, yeah.
So I think I would answer the second phase of your question, right? So I think for DevOps engineers, you really want to do the groundwork, right? Don't get carried away with all the fancy tools or some of the things you can start getting your hands on. You want to go back to your books, go back to the basics, learn about Linux, because a lot of things you'll be doing is still Linux on the cloud at the end of the day. So if you need to install Ubuntu or something to get you closer to that, you need to do that. So do more reading, do a lot of practice, find at your, after you read, you can pick up a pet project, read up, follow popular engineering blogs of companies that, like for example, I'm a big fan of Loft Labs. So I follow their engineering blogs a lot. So you could also, look for some of these companies, look for their blogs that you could follow and learn from, and see how you can apply some of those things in a pet project of your own. Because what you don't want to do is you don't want to gain the experience while you're on the job, right? I mean, for some company, they allow it, but in some places, it's a very strict policy. So it's always better whereby alongside all your readings and everything you're doing, you're practicing, time to time, picking up pet projects, building things. This will also, build up your GitHub profile and improve your chances of getting, higher, and even improve your, general knowledge around how these things works. Thank you.
Yeah, I want to say real quickly, totally agree with what you mentioned about learning the base skills. This is extremely important. Learning Linux, learning DNS, how certificates work. You need to know this. So as a practitioner, starting by really mastering those things is very important. There's a worrying number of DevOps engineers that I know that cannot really understand those concepts deep enough, and this is very, very important. Reverse proxy, all those things, and from there it's easier to build because, as you mentioned, Alex, everything is Linux in the cloud, one way or the other. So knowing this very well helps tremendously. I want to say for personal, it also it's kind of ties to a first question that you asked, like how can someone start a journey, right? I feel don't be afraid to create content. When you're learning, I think Divine mentioned that, when you're learning and asking questions, put out a blog, create a video. It doesn't have to be amazing, but that would be something important.
All right, thank you very much. Does anyone have anything to add?
Yeah, I
Yeah.
want to add a few things.
Sorry, you
Thank,
don't know.
thank you. Okay, I would say you should not be scared to apply as a beginner or whatever level you think you are. And I would say when you're applying, you need to be very, very clear in your resume. And when you're building projects, you need to have a clear goal. For example, now if I say, okay, maybe I just learned about containerization and I want to build a project, it's not going to be enough to just write a Docker file that starts up your website. Go go extra. Do something like Docker Compose, string like different containers together that does something meaningful, and then you talk about it online. You put that on your resume, you put it on your LinkedIn, your Twitter, and you can also ask for feedback. And also I would say try to apply to speak at events. You don't have to be working at a fancy place before you can apply to speak. Because when you go out there, you try to apply to speak, you would be forced to rethink. Because I think for this actual talk, I had to rethink my approach. I want to submit a talk, you have to be very succinct. Like, okay, what do you want to talk about? How's it going to benefit people? What are the things you're going to talk about? So that also forces you to like rethink these things and improves your view of things basically. And another thing is when you go out there, when you're networking with people is not just come and give me a job. You're networking with people to learn what they know, learn from their experience, and also apply it to yours. And when you finally get that job or internship or whatever, don't be scared to do things. Don't be scared to try things out or ask questions, because those are like the only ways for you to grow. There's a project, you've been assigned work, you see someone doing something interesting, like maybe they are working on maybe a new concept like monitoring or whatever, containerization or Kubernetes or whatever. Try to talk to the person like, okay, can I shadow you on this project? Can I see what you're doing? Can we talk through code together? So doing those things, being proactive is going to help you go far in your career. Thank you.
Thank you very much, Mary. Femi, over to you.
Yeah, okay. I just wanted to add, right? For personal engineers that are trying to delve into DevOps, also aside from learning the basics, like Alex said, right? It's also important to, because as you learn, there are several resources online, YouTube, Medium, several resources you can learn with. It's also important to know how these things actually work, aside from knowing several tools, because there are several tools now. But there's someone somewhere writing a tool right now as we're speaking here, right? Trying to release a version or contributing to open source, those tools will keep coming up. And these tools are built on the basics, right? I think Alex was the one that said everything is actually Linux on the cloud, so you have to like have that basics, first, and then you can easily pick up any tool, to be honest, because these tools are actually built on these fundamentals, so it's very important, as you learn and as you go on. Yeah.
All right. Thank you very much, Femi. All right. I think that covers everything about this panel session. Thank you very much for for all the speakers. Everybody has spoken. Everybody has given answers to questions, and it is deeply appreciated. So I will hand off to Victor now, and he'll take it from here.
Thank you very much, guys. It's been a very wonderful session. I really appreciate all of our speakers. I appreciate all of our listeners on YouTube. You guys have been awesome. You guys have been amazing. I know what everyone is waiting for me to announce the winners of our giveaway. So yeah, drum roll. We have 3 winners. We picked 2 from Twitter and we picked 1 from YouTube live chat. So in 3, 2, anytime from now, the names of our winners will just show on our screen. The first winner is winning 50K. The second winner is winning 30K, and the third winner is winning 20,000 naira. Please, everything I'm saying is in naira. Thank you very much. So yeah, let's get we can see the winner on our screen. The 50K winner on Twitter is Swap Devs. That's our 50,000 naira winner. Swap Devs, please DM join Localhost NG on Twitter with your account details, and you will get your 50K today. The 30K winner is Wale Buluwatife, also on Twitter. You should reach out, DM join Localhost now with your account details, and you will get your 30K. And the last winner we have here for 20K is Fabian Emezu on our YouTube comment section. Also, Fabian, if you're on Twitter, you can drop your Twitter handle here, then send a DM to join. Look, let me confirm the handles. But I'm sure it's join Localhost. One sec, please. Yeah, join _Localhost on Twitter. DM the account number to them today. In fact, right now, and these monies will be transferred to you guys. Thank you very much, guys. You guys have been awesome. We've had multiple events that are in person, and I still enjoyed myself even when we are not in person. I'm able to connect with people on a different level, even without seeing them. Thank you very much. Also, a very big thank you to our sponsors, DevOps Dojo. Thank you very much to our sponsors. Also, for these events you are seeing here, there are people that are working tirelessly in the background to ensure things are running. Every time you see me come here and I leave and somebody else comes here, there is someone in the backstage that is doing all the editing, dropping the names, switching the slides. A big round of applause to Praise. No, sorry, not Praise. To Favor is being the guy that is doing all the work in the back end. We just show up and take all the praise and take all the praise basically. So shout out to Favor, shout out to Ido, shout out to Praise, shout out to Dio, and every other person here. We say a very big thank you to you guys, and to our speakers, thank you very much. See you guys again, same time, same station, hopefully in person next year. Also, don't forget to join our community. Follow us on Twitter, on LinkedIn. We have a Slack channel in the chat. Also, all of this recording will be hosted on YouTube. So feel free to share with your friends, like, broadcast, subscribe, and yeah. Thank you very much, guys. I think that will be all from me. Thank you.